Hello and welcome everyone to another episode of the WeAreDevelopers Live Days. My name is Bene and I'm here at the WeAreDevelopers headquarters in Vienna, and I'm happy that you all made it to this very first episode of the new year and our new season. Very welcome. So today is all about Java, but before we start with the first speaker, just a quick reminder for our regular viewers and as an info to our newcomers. The WeAreDevelopers World Congress is back as an in-person event in Berlin in July. Go to worldcongress.dev to get further information and to claim your tickets. And now, don't forget that you have a chat to your right. You can use that to interact with the other viewers or submit some questions to the speakers if you got any. But during these interactions, please be nice to each other and respect each other as we have a code of conduct. Here's a short video about it. And now let's start with Java and the first speaker of the day. He is co-founder and chief technologist at Camunda. He authored in 2 books, namely Real Life BPMN and Practical Process Automation. He regularly speaks at conferences such as ours today, and with his over 20 years of experience in software engineering, he certainly knows what he's talking about. Welcome, Bernd.
Yeah, thank you. Thanks, Bene, for the introduction, and let's see if I know what I talk about.
I'm pretty sure you will. First test, would you mind actually telling us a bit about what we are going to learn from you today?
Yeah, I mean, you already said it in the title. Did you say the title? I probably missed it. It's about long-running processes, so about the problem we see in a lot of architectures that we have to wait for certain things. There are multiple reasons why, and that's not super easy, straightforward to implement, also not in Java, and that's my topic for today.
All right. That sounds very interesting, Bernd. I'm sure you got the full attention of the audience. You got mine. And I would say without further ado, the stage is all yours.
Yeah. Again, thank you, Bene. Thanks for having me. Good morning, everybody, or good evening, good night, depending on where you join the live stream. Right. So long-running processes. In order to get started, let's talk about food. And I always like metaphors, and I like making kind of comparisons to real life situations to also discuss certain, let's say, tech problems, because for me that makes it always more tangible, and probably I also get hungry by looking at those pictures. But anyhow, if you order pizza, let's assume you want to order pizza now, then you have multiple options to do though. Actually, if you live in a very small town like I do, the only option you have is you have to call your pizza place, which I'm pretty sure you cannot do at 10 a.m., which is at my place at the moment. But that's a phone call, right? So you pick up the phone, you dial the number, you wait for the other party to pick up, you give the order, and so on and so forth. You know how a phone call works. And looking at like the technical analogy, that's what's called synchronous blocking communication. It's synchronous. I get a response directly. It's blocking me from doing anything else, right? So synchronous blocking communication. It has a feedback loop built in, so I directly get some feedback from my pizza plates if they can do their order, if they are whatever, if they're busy, how long they think it will take, and so on and so forth. But I'm also temporarily coupled to the availability of the pizza place. If they're not open, if they're currently busy answering the phone, if they're whatever currently at the toilet and can't pick up the phone or whatever, if they're not ready, I can't phone them. I have to do it again, retry, and so on and so forth, right? So synchronous blocking communication. I know, very basics. We start with the basics here today. But we get into more interesting stuff pretty soon. The other option you would have probably is sending an email. You could send an email to your pizza place saying, okay, I want to have this pizza. The difference now is that we have a queue in between the email inbox, basically from the pizza place. So it's asynchronous and non-blocking, right? There's no temporal coupling, even if the other side of the equation is currently busy. I can still send my email, so I'm done. I'm not blocked waiting for the thing, right? Because I rely on the queue actually delivering the email. How does it make you feel sending an email to your local pizza place? Not sure about you. For me, I would get very nervous actually if I really get a pizza. So I might actually pick up the phone asking if my email went through. But one way of avoiding that, and it's not the asynchronous non-blocking communication, which is the problem. The problem is I don't get any feedback. So you, of course, can still have a feedback loop so they could answer the email saying, okay, we got it. Right. And again, that could be asynchronous. They send you emails, so they are not tied to my availability and so on and so forth. Right. That's the very basics we need in order to discuss certain scenarios later on. So synchronous blocking communication, the phone call, asynchronous non-blocking communication. Makes sense, I guess. And of course, I know most of you would simply use an app or a website to order the pizza. I'm jealous of that. But we will see that the patterns are kind of the same. Okay. The one important thing here is also the feedback loop is not the result you want to have. So just that they say you will get a pizza doesn't mean you stop being hungry, right? You haven't yet have a pizza. The pizza is the result. And the task of pizza making, it's what I call long running, right? Because they have to put it in the oven. They have to wait for whatever, 5 minutes, 10 minutes, 15 minutes, depends on the pizza place and the utilization and so on and so forth. And then you get the pizza. So there is an element of what I call long running in here. And that means I always have a delay getting the real response. And we will see also later on that this is a quite typical pattern now that we see. We might have a first step that is in a way with a feedback loop, maybe synchronous, maybe not, but in a short time frame. And then we have a long running step to get the real result. And you can easily imagine that. And you can also imagine the other way around, like saying, okay, what if I use, for example, synchronous blocking behavior for the result? And the way I always imagine that is walking to a local bakery around the corner here, which is not that picture, but I think you know these kind of like small little bakery shops, and they normally also have a coffee machine in there. And if you order coffee there, that's synchronous blocking behavior, right? You order the coffee, and the person behind the counter turns around, walks to the coffee machine, presses a button, needs to whatever clean up the mess first, and the other person doesn't do anything in that time. You're not doing anything, you're blocked. The queue behind you gets longer. If you order 10 coffees, that's a fun exercise to do, and so on and so forth, right? So it's pretty easy to imagine this is a bad user experience, actually, and it also doesn't scale very well. So we don't want to block for the result. And if you imagine coffee, if you're not so much into pizza at that time of the day, if you imagine coffee, you could imagine something like Starbucks. And there's a quite good article, blog post actually from Gregor Hoppe. You might know Gregor Hoppe from the Enterprise Integration Patterns book. It's relatively old, but I still find it a really good resource. He wrote about why Starbucks doesn't use two-phase commit. That's the title of the article. But it really shows exactly that. So you have that first step of ordering, of paying, which is kind of, in a way, synchronous blocking, right? And then the order goes into a queue. It's written on a piece of paper, basically, and then the baristas doing the coffee, they're scaled independently of the cashiers. And then at some point in time, the coffee making is also a bit long running. You get the coffee and they call out your name. That's kind of a correlation identifier. So they make sure you get the coffee. And you can already see that this scales much better. It's a better user experience. And what I also find very interesting is you have more options to adjust the user experience or the customer journey, if you will. So you could, and a lot of companies now do that. You could replace the step of paying and ordering with a simple app, which you do already when you walk in the store, or probably even before. So you adjust the journey because you now have flexibility to do so. And it would be really hard to automate, for example, the coffee making, but it's relatively simple to automate the ordering. Okay, so right, synchronous blocking, non-blocking, we have the feedback, not the result is later, and we have long running. And long running is the topic for my talk today. And if I say long running, and I like the term actually, and so I keep using that very often, but if I say long running, it normally means that I have to wait for something like the pizza in the oven, right? It's not that I actively do something like massage the pizza so it gets ready. It's like I just wait for the time to pass. Or same with the coffee, I might need to wait for the coffee machine to warm up, for the coffee to get through and whatever. So there is normally a lot of waiting involved, and that's what I want to talk about, and that's what I mean when I say long running. It basically means waiting. And there are lots of reasons why you want to wait. Some typical business reasons, we will come to technical reasons later, but some typical business reasons, so requirements are, there's human work, so you might want to push certain tasks to users in order to do something, and then you have to wait for them to get to work, to pick it up, to do the actual stuff, and so on and so forth. There are a lot of moments where you have to wait for responses, like whatever you want to open up, or you want to create, apply for a new insurance policy. You do all the paperwork, and then you have, or you get all the paperwork from the customer, and then you have to ask for some additional papers or something to sign off, and then you send a mail to the customer. Need to wait for the response, and that will not happen in milliseconds. That will be much later. Or you simply have to let some time pass. That's I put the pizza in the oven and then I simply wait 10 minutes. Or one of my personal favorites was a startup actually that automated a service which was 100% automated. So that ran through in seconds, but they added they wanted to have a wait state in there for, I don't recall exactly, 30 minutes, 45 minutes, because they sold it in a way that it's kind of crafted that a human does all the work. They wanted to have that impression with the customer. Oh, somebody looked at that and did a lot of work. So it should take longer. Or bias remorse was an example I liked also very much, that there's kind of scientific research that shows that after you bought something, you might regret it, and then you might cancel your order right away. So within the first minutes or within the first hours, there are the most cancellations actually happening. And if you start fulfilling the order right away, the cancellation might be really hard because you probably already picked stuff from the warehouse, for example, and then it's really hard to cancel the order, or the parcel might already be on the way and then you have to return the parcel and so on and so forth. It's much more expensive. So it might make sense to wait an hour before you start to fulfill the order, and so on and so forth. There are hundreds of good examples when you have to let some time pass. And implementing that is actually painful in Java and all the other languages. I picked Java here because we're on the Java day, of course. Why? Because you need to have state, right? You have to remember that you're waiting. It's kind of I'm not sure if you're even thinking of having a thread open for days to wait for something. Of course not, right? So we have to write that state somewhere in a database, for example. We have to keep it persistent so we remember we're waiting. Now you could argue, and I see that happening a lot actually in a lot of scenarios. Okay, that's easy. Let's add a database here. Let's put an order in the database. Let's give it a status column, like order entered, order paid, order fulfilled, and that's it, right? Then we have a state. Where's the problem? Then we can wait. And the thing is, as soon as you start doing that, you get subsequent requirements around the state handling. Like you want to see what's currently going on. Where are you waiting? Where are you waiting for too long? And you probably not only want to see that, you also want to do some escalations automatically, for example. Oh, if the customer doesn't pay within 2 days, we need to remind the customer, or after 5 days, we cancel the order automatically, or right? There are a lot of these examples. Or you want to And if these escalations, for example, if there are failures during escalations, you need some possibility to do something with that exception you might get, because there's no client available anymore. You cannot just rethrow an exception. You have to have a monitoring capability. If you have long-running things like think order fulfillment, you always have orders circulating in your system. If you want to change the logic how to fulfill orders, you have running orders and you have new orders with a different logic. So you need kind of a versioning capability. And it's very often domain logic we're talking about that. I'm getting to that later in the talk as well. And you have to do that reliably and so on and so forth. So it's actually not that easy. And in my career, I'm doing that for 15, almost 20 years now. I saw so many homegrown kind of workflow engines. I get to that in a second, because people underestimated these kind of requirements they get around the state handling. So it's all about how can we solve the problem of long running without adding accidental complexity like the database table, a scheduler, this and that and that. That must be easier, and it is easier. The one thing I want to say here, full disclosure, I'm like every human being. I have an opinion. I might be biased. Just making it transparent. So I'm co-founder of Camunda. Ben has said that very briefly in the beginning. We're an open source process automation, process orchestration vendor. Right, we're out there for quite a while, but that's also the perspective I'm thinking about problems. So I'm kind of since the beginning of my career, I'm doing something with workflow engines, orchestration engines, and these kind of things. So that's my bias, right? I'm thinking through the lens of workflow engines about problems. The most important thing about that slide is if there are any questions afterwards, any feedback, there's my email address. You find me on LinkedIn. Just connect and ask whatever you want to ask, right? Or discuss whatever you want to discuss. Good. So keep that in mind when I keep talking. So obviously there are solutions for long running. They're called workflow engines. It's a pretty still the most popular term, I would say, but you might also call it process engine or process orchestration engine. It's kind of the term of the day. But it's normally all means the same. It means that you have a piece of technology that can where it can express certain processes like steps in models, very often graphically, version them to solve the version problem, keep them durable, persistent, have all the tools around that for management, operations, and so on and so forth, and also have scheduling capabilities, right? So that's the idea of a workflow engine. Okay. In order to make that more transparent or more lively, let's quickly look at that. And I'm going into a quick example, and you have all the code on GitHub. You have the link here. I keep it open for a second so you can still scan the QR code, but I'm happy to also put it in the chat later. And if we're going there, right, I'm going to my IntelliJ in this case. I have a Spring Boot project here, so nothing very surprising, Maven and Spring Boot and Java. And what I have as part of that process is not much. I'm depending on something called CB. That's our workflow engine. I'm basing this here on our SaaS offering. So I have created a cluster in our SaaS offering. That's one way of doing it. There are others. I'm not going into details of that. Having that running in the background, having a client SDK connecting to it, having a couple of properties, how to talk with my SaaS instance, and that's kind of the setup. And then I have a process model as part of my project here, which is customer onboarding. That's the example I use for the quick tour. I use a graphical BPMN model, business process model annotation. It's an ISO standard to define these processes, and then I can basically define the different steps I want to do in order to onboard a new customer, which we have in almost any industry. It might be opening a bank account, applying for an insurance policy, get a new mobile phone contract, whatever, register a new domain, whatever you want to pick as an example. They always have onboarding processes, and they're almost always kind of the same. You score or you do clearing, you approve or disapprove. If you approve, you provision the thing, and then you're done. Right, so I want to do a very easy scoring, approve the customer. That's a so-called manual task. That's a service task, a system task, and that's more or less it. Right. I need to have a look on the time, so I'm not going into all the details here. I want to highlight one or two things. So one is scoring the customer. What does that mean? How do I score the customer? One of the key ideas here is I glue the graphical model in the workflow engine to actual code. So score customer as a so-called task type. And that is this connection to some Java code I have here. So it's a Spring Bean. It's a so-called job worker. The job worker makes a connection to the workflow engine. And then that is the task type. I could also refer to it here, but the default is just using the method name. So that's the connection. So now when I start this application, it knows that whenever I have a new workflow or process arriving in that state, this code should be executed. And if that's done, the process moves on. And then I go into a user task, which then has a form connected to show it on a kind of task list. Okay, cool. Last thing to quickly show you, and then I also have a REST API here in front of the whole solution, which can start new onboarding processes where you say, okay, I basically put some data, probably copying that from the request and start a new process instance, and then we're good. Okay. With all of that, I also added, and I always am happy to show that, a very simple HTML page. That's my level of HTML I'm happy to do, with a bit of jQuery to just kick off that REST API, right? So it's not because I propose this is the best web UI you can ever do, but I like that it shows the simplicity of the what you actually need. And then we end up with a beautiful UI. Always like that, where you, for example, can open a new bank account and probably enter some data. And then I push the button in the background. No, I think StreamYard over here. Okay, I think we're back. So it started a new process instance successfully, and then you have all these kind of tools where you can look into, hey, what's going on? Okay, I have a new process instance currently going on. It waits for approval. It already did the scoring. There's some data attached, and so on and so forth. You have a task list. That's exactly about all the long-running things. So I see I need to do an approval. I see the data. I can pick it to do it personally, and I can confirm this should be automatically processed. And then this kind of moves on. I see that and operate in a second, and we see how to take it through. Okay, good. Yeah, right. And it sends an welcome email. I haven't showed that, just a very quick thing. But there are also, if you don't want to connect your own code, you can also use pre-built connectors. And I've built my customized one for a different demo, actually, which always sends a SendGrid email. So that should probably also have happened, or it doesn't. Probably my SendGrid. Yeah, okay. I haven't added the SendGrid secret in the preparation here, but that's not a problem. Actually, it gives us a good opportunity to see what happens if something fails. We talk about that in a second. You see, there's an incident in my process. You see a big red light. You can dive into that. What processes have those incidents? You can see where it's at. You can see that's what I had early on. You can see the full message. You can retry it. So I could add the secret now, and then I could retry it, and it just moves on. Okay. And just for the long running part, I could also add now things around the notion of time. So I could say if approval takes too long, timer boundary event, non-interrupting, the dashed line says, okay, if that takes too long, I do something else additionally. So I keep waiting for the approval, but I, whatever. No, I can't say kick ass. It's not politically correct, but remind somebody to do the approval. I could probably do a user task again, assign that to a manager or whatever the role is. I save that. I can restart my application. In this case, it's built in a way that it does an auto deployment of my process model when the Spring Boot app comes up. It deploys it, so I should have a new version of my process. Seeing that in a second. And then if I submit a new application here, it's interesting. My super fancy HTML page seems to bring my Chrome down when I have StreamYard open. I have to look into that sooner or later. What's happening here? Oh, we have an exception here. Okay, my process model was not correct. I didn't configure the timer. So if I say a timer, I have to say how long. So we could say a duration period time 10 seconds. Okay, made the process model correctly. Start again. I'm not going into any product details. We have actually a linting tab in the modeler that would show me a lot of those things as well. Bam, we should be there now. Okay, refresh. Yes, I can start a new application. And then if I go back to operate, I'm looking at my onboarding process. I have the new version. What you can see is that the old process is still running in the old version, for example, and the new one is here. And if I talk for another couple of seconds, I see that this is also escalated. And yeah, this kind of things. I hope you get an idea of what I mean by workflow engine, what I mean by workflow or orchestration technology to solve long-running problems. Okay. Yeah, that should be okay. I just wanted to give you an idea so you can better connect that with what I'm talking about next in your mind. Just to recap, as the solution architecture, what I had was just a simple Java Spring Boot app. I had an SDK. I used Camunda 8 as a SaaS version. And then I had custom code to connect to a REST endpoint, for example. Or I had my, don't have that on the slide, my connector to connect to SendGrid, for example. Okay. Good. So we talked about these business reasons why we want to wait, which are very often front of mind when we say long running. But there are also technical reasons, which very often are also motivation to go into that direction. And for example, what I said in the beginning, if we do asynchronous communication, for example, with messaging, and then we might wait for responses. Like we want to see that the feedback email from the pizza order arrives within a certain time frame. And if we assume that's not milliseconds, but probably minutes, then this starts to get a long-running problem where we don't want to wait in a thread anymore. And this gets especially interesting if we look at failure cases, if the response doesn't arrive, because then we very often have to do something around that. And very often it's long-running. I'll give you an example in a minute. Also waiting for availability. That might be in the synchronous case that we can't call the other service because it's not running at the moment. What do? We have to wait probably, right, for it to become available. That's kind of the situation. We don't get a response because the peer might not be available at the moment. Okay, so that's a very, very common thing. I already showed you that in a way with the incident. So if the peer is not available, you get an incident in the workflow engine. You have automatic retries and so on and so forth. In the matter of time, I'm not going too much into that. I'm happy if you ask questions around that, then we might use the Q&A to have a deeper dive into that. I wanted to, again, go on the metaphor level a little bit to also give you an idea why you probably want to use something like that. And one of my favorite examples is this. In a live setting, I normally ask you who has used an airplane before, and then most of the people raise hands, which is good because then you know the procedure, right? You normally book a flight, and then you get a check-in invitation a day before your flight takes off, right? And you should check in. And I got that for a flight to London, actually, quite a while back, pre-pandemic, actually, this example. And when I did that and I wanted to check in, I did everything. I pushed the button, and then I got this error message basically saying, hey, there was an error while sending you your boarding pass. So I couldn't proceed. What's the normal reaction? I can't ask you, unfortunately, but it's also for computer scientists very natural. I retry it, right? I try it again. My wife always gets a bit crazy. Why should it work if I try it again? Trust me, try it again. But it didn't work in that case. What's the next thing you do? You wait a couple of minutes and try it again. And it didn't work. What was the next thing you do? At least what I did was, because it was still 24 hours till the flight, so it was not in a hurry. So I made an Outlook entry in my calendar to remind me to retry the check-in in, I don't recall exactly, 4 or 5 hours. And that's exactly what I wanted to get to. I need that retry, but in a long running matter. And the situation I envision, we're not working with Eurowings, but we're working with comparable companies. And the situation I envision is that we have a couple of different services at play, microservices or whatever, but we have different components we need in order for the check-in to work. So for example, the 3D barcode generation or the output management to generate a PDF or whatever, or I think it was British Airways that still offers to send you the boarding pass as fax message. So then you have that component somewhere. And we see that all the time, right? We need more and more components in order for one functionality to be delivered. And what I think happened is that some of those simply broke. And that's in a way fine. I mean, the situation we are approaching nowadays with more and more services, more and more SaaS services, more and more components we need in order to deliver functionality is very different to the monolith we had built 20 years ago, where we could say, okay, we put a lot of hardware in it, we just make it highly available. That's not the mindset we have anymore. We say we have more and more components, and some of them will always be broken, right? Or the network towards them will be broken. So something will happen. And that's okay. We need to deal with that. What we have to make sure is that it doesn't like really brings down like the whole system completely. And we need to be resilient with those failures. And thinking about that in the check-in case is if there is a problem with the barcode generation, what we actually should do is we should deal with that in a very local scope. We should not, as the example was, we should not bring that really up to the user experience where we say, oh, we can't check you in, there's a problem, any kind of problem, but you have to deal with it, right? That's a bad design, right? That's a bad architecture. And in this case, it's very obvious because it's me as the customer in front of the screen. But this is kind of the mindset I'm still seeing with a lot of, let's say, service-to-service interaction within organizations. The mindset should be very different. These should really be right. And that's a funny part of that story. And it's really the same trip when I had my onwards flight from London. I had the same problem with EasyJet. We have technical difficulties, right? So they couldn't check me in. But the interesting part is, and that's different, they give me the work instruction to work with that. So please log again. Hey, retry. If that doesn't work, please try again in 5 minutes. Okay, increase the interval. And I love that most. We do actively monitor our site and will be working to resolve the issue. There's no need to call. It's your problem. Please sort it out. It's not our thing. And I mean, that's attitude-wise, I think the wrong thing. They should be much more like, okay, we are having technical difficulties. We're sorry. That can happen. We try everything we do, and then we will let you know, right? We don't make it your problem. It's our technical glitch. We make it our problem. We solve it. So like looking at the architecture, that would mean the check-in service should solve that on itself, right? And then it never leaves that scope. It makes a cleaner architecture because the web UI or whatever other component is never really influenced by these like technical problems the check-in has. But that also makes the check-in service at least what I call potentially long-running service. So it might take time in failure cases. It might deliver a response in a millisecond if everything is great, but it might not. And it's a much better architecture to deal with that, to think about that possibility of long running. Okay. And very often when I say this or when I discuss that, I get the the headwind, if you will. Yeah, but the customer needs a synchronous response. And I discussed that with especially one customer I recall very, very thoroughly. They were in that, no, we need a PDF. People want to print it out right away. We need that synchronous response. And if you think about that, I find that 100% nonsense, because if the choice is you either get a synchronous failure message where you left alone with, or you get a proper result later, I mean, I know what I would take, right, as a user, because there's, I come back to that later on as well. I mean, you can still provide the PDF to print out if everything is fine. Okay, I don't have any problems with that, but it should be treated as a special case. I mean, even if it's hopefully the normal case, you should at least think about that this is not the 100% case. There are a lot of edge cases where this will not happen, and it would be good to still operate properly. Okay. Quick detour, which I find important. So we talked about retrying things. If you implement retry, also implement idempotency. And that's one of the big obstacles or challenges I see companies having when we start adding long-running capabilities, adding retries. They very often deal with services that are not idempotent. Let me quickly explain idempotent. So let's assume you have a payment service that wants to charge a credit card using a credit card service. Then you have an API call to charge. And depending on the basically how the API is designed, that could mean that you charge the credit card just giving a credit card number and the amount to charge. Right? This is not idempotent, because if you retry that, the target service don't know if it gets the same call twice, if it's the same call just retried, or if you want to do just the exact same charge twice. It might be, right? Especially if you look at whatever, consuming music or videos on demand, and you might buy 2 pieces of music for the same price or whatever, right? The thing is, if you have an API design like that, it's always guesswork. It's best effort to see if it's a duplicate or not. And that makes it sometimes incredibly hard for this service to detect duplicate calls. And that makes it hard to decide that you easily go for retry. So you should always, whenever you have the choice, doing APIs that have some kind of, for example, a transaction ID, where you can easily detect duplicates, where it's idempotent because you can call it again, and the credit card service can immediately know if it already charged for that transaction ID or not. And the trick is normally to create that kind of artificial ID very, very early on. So probably already in the UI. You can create a UUID and just pass it along, and then everybody along this chain knows if it's a duplicate or not, and that makes it incredibly much easier to apply retrying on a broad scale. So that's in a way not long running. I agree, but I find it an important ingredient to move along, right? Because I find this an interesting example. I discussed that with one customer quite a while back, in depth actually. So assume the situation where you want to charge the credit card, right? And assume you're using a workflow engine for that, because then you can do retrying, and you can do retrying in a stateful manner, saying like, I retry that for 10 minutes or an hour or 2 hours. So that it's the same like the check-in component retries the barcode generation unless it's successful. Right? Until it's successful, right? So you could do that. Hopefully, the credit card service is idempotent. But still, at some point in time, you might give up, right? Hey, we tried it for an hour, no way, the payment failed. And if you do that, there's one interesting thing also to keep in mind. If you have distributed system, network communication, it's impossible to differentiate certain failure scenarios. Like if there's a network error, you might never reach the service provider. You might have reached it, but it exploded during doing your request, or it might have committed its transaction, but the response got lost in the network. And you have no idea which of those happened. There's no way of doing that, right? So, and it's independent if you're using REST or messaging or Kafka or whatever, right? There's no way of knowing that. And that means in that scenario, right, you retried that 5 times, you never get a response, and you say the payment has failed. You might have actually charged the credit card. Technically possible. If you don't have an idempotent service, you might have charged it 5 times, right? So very often it's interesting to look at those cases as well and saying, okay, we want to probably refund or cancel the charge. So there might be things we need to do in order to clean up. Okay, it might not be the best way to do that with the workflow engine. I'm not saying that. There might be reconciliation shops running at the end of the month or whatever. But it's one interesting possibility, at least, to have in your tool belt. And then because the service was not available when charging, it might not be available when you want to cancel the charge. So again, that might be long running. And that adds a lot of reliability to what you do. It adds a lot of resilience to what you do. And then the example I had earlier on, then you can still build a service which gives you, hey, payment received as a synchronous blocking response via REST if everything works fine. But if not, you probably just get a REST code 202, which means accepted. We got your request, we sorted out, and you need a callback mechanism or a messaging mechanism to send the response later on. Very, very important pattern. If you, we don't have time to look into that today, but there's also code showing all of that in more depth available on GitHub. Cool. So for me, one of my key points I wanted to get to is like long-running capabilities, so the possibility to implement long-running easily are essential to design good service boundaries. And this is, from my perspective, very often forgotten. Right? And I make another quick example. I'm an example person, I'm sorry. I hate theory and slides. I always look into examples. Let's assume you have a booking site for whatever, train ticket, flights. You have a payment service and you have the credit card service. And the booking says, hey, retrieve payment for me. Might be a REST call, might be messaging. It doesn't matter, okay, for the sake of the example. Payment says, okay, in this case, I want to charge the credit card. So I charge the credit card and then I get a rejection message. The credit card was rejected. Now, there are a couple of different possibilities what the payment service could do now. It could either forward that rejection, credit card rejection, to the booking service. Probably not the best idea, but it could do that. Let's simply assume you have kind of an architecture like that, and then you get a business requirement of saying, okay, if the credit card was rejected, the customer can provide new details. And this is very often if you have your payment details in your account and probably the credit card expired and you want to give people the opportunity to update the credit card. And probably with a good user experience. So a common example is something where you have a subscription like GitHub. If GitHub renews, your credit card is expired, they send you exactly an email saying, okay, credit card expired, we want to charge. Resolve that within, I think, 2 weeks is the time frame they give you, and then everything is fine. I would love to see that also for other things, like book a train ticket, and the current user experience is if the credit card is rejected, my whole booking is kind of gone. It just says, oh, payment failed, and then I have to redo everything. It would be great if they say, okay, we got your order, it's there, we reserved your seats, they're blocked for another hour, but your payment failed. If you update your payment method and if it goes through in time, we're all good, we send you an email. If not, we can still cancel that pending order you have. That would be a very different way of designing the customer journey, but a much better user experience. And one of the key things in order to make that happen would be really here to be able to implement those requirements properly. For example, what I see happening very often with this requirement, it ends up in a booking service, because the booking service is long running anyway. They have stayed, they have solved that. So, hey, let's put that requirement there. And then the booking service grows and grows and grows. And it does things it's not responsible for, because payment is responsible for payment. I mean, that's kind of obvious, right? So we should actually write, and then you end up with things like, this is Sam Newman. He wrote microservices books, pretty famous ones. And he says, along the lines of criticizing orchestration for weird reasons to some extent, but I agree with him to disagree on certain things. But he says, for example, then you end up with a few smart God services tell anemic CRUD services what to do. And for me, that's very often the reason, because only those, let's say, bigger services have the possibility to implement long-running capabilities. Then you end up with this, but it's not a given. So it's even much better to say payment should solve that, because then payment could be potentially long-running, right? They could sort it out, and they never ever give the ticket service or the order fulfillment service some response saying credit card expired. You only get a response that payment was either received successfully or ultimately failed, so you don't even retry anymore. And that's a much better design. It gives you much cleaner services. And then you might end up with a long-running service also in payment, and probably even in the credit card processing. So that's kind of where I want to get to. So if you have the possibility of, or the capability to implement long-running things easily in your architecture, you can use that at the place where you need to, and then you can build a much cleaner architecture overall. Also looking at microservices, for example, because then you could, for example, extending payment options and so on and so forth. We're not looking into that too much today. So, right. I said all of that already. And the only thing I want to add here, which I find important because it's asked so often, and it doesn't mean just because I use a workflow engine or an orchestration engine that I get a monolithic process or whatever. There's very often misconception about that. And you can have processes in all of those services distributed and so on and so forth. Okay, if you want to know more about that, let me know. And very last but not least, graphical models, really, that's the other conception I sometimes get. We want to solve these long-running problems. We want to code. We are Java developers. Why should I use graphical models? And the thing is, I have really, really, really good experiences with BPMN on all levels with different stakeholders. So first of all, it's living documentation. The process model you have, the graphical one, it's running code. So you always have that place where you can understand the thing. And especially with long-running things, you have to talk through them with more and more stakeholders, actually, because there are questions about why do we wait there? How often do we cancel there? What's the right waiting time? What can we do if that's not happening, and so on and so forth. So you have typically very often discussions around that on a business level, and this is so valuable to have these kind of graphics you can look into, which are not wishful thinking, which are not documentation, they're really code. They're used at all places. That's a screenshot from when we run test cases. You can create these kind of reports for a specific test run. So you see what's happening there, what's the test coverage, or all the tools you saw earlier on, what's happening. We have a lot of also statistics, and you can see bottlenecks and whatever. So there are a lot of insights you can draw from that, which makes it very, very, very powerful, actually. And I personally never understood the reluctance to use graphical models, but I just want to invite you to give it a severe try, because it's simply very powerful. And a lot of last thing, I promise. That's the thing I see at the moment being very, very important. We do a lot of changes on a technical level, microservices, cloud SaaS services, and probably even serverless things or whatever. So we change the way we're building and deploying applications, but it influences the user experience and the customer journey. It also influences the possibilities I have doing that. And I had a couple of examples early on. And that means a lot of those things needs to be discussed with the business people because it's about requirements. What's the consistency level we want to guarantee? How long can we be inconsistent in certain cases? That's a business decision. And that's why it's another reason why I think having graphics that help us communicate that are essential. So let me recap. So we need long running. We need technical capabilities to solve long running, right? Process orchestration engines are a great fit. Camunda, obviously, but there are others as well. Go get a look yourself. And that allows you to design better service boundaries and embrace asynchronicity. It's not a problem anymore. It's actually easy to handle, and it really results in a better customer experience at the very end. It's also fun to use. If you want to learn more, you can either get to our homepage and try it out. You can get to the GitHub examples I added to try it out. You can, of course, read my book. And that's all I have. Thank you so much. Let's see if we get Bene back.
Thank you so much, Bernd. And hello again. After this wonderful talk, I could relate to the comparison with the pizza in the beginning. I had yesterday a pretty good one. And the way was also worth it. All right, Bernd. We still got some time left and some questions. So I would say let's jump into a quick Q&A.
Let's go.
The first two questions are, I think, easy and are kind of connected to each other, because first one would be, what is the name of the product? And as a follow-up question, is it open source? Can I use it in production for free?
Yeah, so the name of the product is like the name of the company, so it's Camunda. So that should be easy. I had it on the slide, CAMUND, as you can read it here.
We can write it in the chat. Yeah.
And yes, it's open source available. That's the correct term, because there are some clauses in there. There's a whole discussion where the difference is. If you're interested in that, shoot me an email. But it's available. Not all parts of it. So there are parts of that which are not free for production use, which is the typical upsell opportunity you want to have as a vendor. But there is a path to use it completely free in production as well. Yeah, that's a quick answer to that.
All right. Thank you, Bernd. Next question. What are the cons or the trade-offs companies need to be aware of when implementing these solutions at scale?
That's a broad question. As it is a very broad and high-level question, I can also only answer a high level in a way. And the trade-off is always, you basically introduce a new technology that always comes with a bit of overhead, a learning curve. You need to evaluate the technology. You probably need to find your way of using that in the company. That's always a bit of an overhead. That's kind of the cost you have. At the same time, you have a gain, which is typically around saving effort, because very often people go into solving that on their own. They're writing code around that, which goes into technical accidental complexity, which simply consumes time and resources as well, especially on the long run maintenance. So that's the obvious one. The other not so obvious one is that very often this introducing such a technology also has kind of a transformational power, let's say, to better understand processes, to better think about long running things, to also better align that with business stakeholders. So that very often helps actually a lot of our customers to also improve their processes quite a big time. And that's harder to put in correct numbers or concrete numbers. And the scale one, just to add on the scale one, it's probably not part of that exact question, but the scale is something we we really focused on a lot over the last years. So first of all, with the technology we have now, we have a horizontally scalable tech, so we can basically go into all the use cases. So we have customers running really concrete money transfer, like big banks on Camunda. So we can get into the multiple thousand instances per second easily. So that works. So that technical scale is solved by now, and we're also currently have customers that run hundreds of different processes on Camunda. So we are also working with them to get all the best practices around how can we help organizations to get to that scale. Do I need some whatever internal expert, internal center of excellence? How can we set up those projects? What are good, whatever golden path or templates we want to use? So also on the organizational scale side, there's a lot of material and maturity at the moment.
So, sounds reasonable to me. Thanks for this answer, Bernd. And let's move to the next question. How accessible and user-friendly are these solutions? Are there further resources or best practices?
A lot, yeah, of course. It's probably more the problem of too much stuff, not too little. No, I mean, again, very generic question. So it depends on what you mean with user. So user, if I look at Camunda as a product, the user could be the developer using it to build a solution. Then it's more about the developer experience, where I would say relatively simple to use. We still have some homework we are currently on, so I hope we're even getting much better over the next 6 months. But it's still really easy to get something going, especially if you use a SaaS service. There's a trial version, so you don't have to set up anything locally. If you look at the end user working with the solution later on, so if you build an onboarding process, there might be people in the company needing to do whatever approvals. It's a very different story, and that's where it really depends on what you're building. So a lot of customers are building their own UIs, or they're embedding that in existing UIs, or you could use Slack as an end user interface if you like to. But there are, of course, also the tools you saw earlier on, like our own task list, where people can work with. And so it's hard to comment on that on generic basic. What's the user friendliness of that?
I see. Thanks for this answer as well, Bernd. Next question. Does Camunda store its state in a database, or are multiple databases supported?
Mm-hmm. So we moved from Camunda 7 to Camunda 8, so a new major version 2 or 3 years back. And the Camunda 7 version was based on a relational database, and there we supported kind of the typical ones, actually. The thing is, with the relational databases, we hit a limit in scalability, also in resilience. So for example, if you want to, we have customers who need, I'm not sure if they want, but they need a geo redundancy. So they have data centers, for example, in the US and in Europe, and they replicate across them. And doing that with a relational database and the architecture you build upon relational databases was actually limiting us in scale. And also, like, running 10,000 of process instances per second is also pretty hard with a relational database. So what I want to say is we switched to a different architecture. It's kind of, if you will, event sourcing underneath, where we do our own state. It's binary on disk, and then we replicate ourselves to our peers. And there you don't need external dependencies for all the, and this is for scalability and resilience. And we now can do even those geo-redundant scenarios. So that adds latency, but it doesn't bring throughput down. So that's actually pretty impressive. The one dependency we still have for all the tools where you can look into things like this operating tool or task list, there we're using Elasticsearch underneath.
Thank you, Bernd. And as a last question, since it's kind of a hot topic right now, have you already worked with Java 21? If so, what do you think about it? Are there features missing in your opinion? I'm
probably the wrong person commenting on that. Honestly, I'm normally the one fighting the fight why we still want to support Java 8 for certain client SDKs. because we have big customers that are really stuck on old versions, and very often but I'm looking at it from we're a vendor, and there you have the differentiating of building the core product. There we're going with the latest Java versions, but we're also providing SDKs to our customers. And those, I'm normally reluctant to go with the latest and greatest because it doesn't give us a big advantage and we want to be compatible. So I'm normally very often in the role of the old is still good. So I'm not the best to comment on that question.
All right. Next time we will not talk about.
Yes, yeah, I prepare myself next time.
Sorry for that. All right, Bernd. And with that, we also come to an end for this Q&A. Thank you so much for the very informative talk and for the Q&A. It was nice having you, and hopefully until next time. Bernd?
Yeah, thanks for having me, Bina. And everybody else, have a great time today.
All right. And before we come to the second speaker of the day, just a 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
All right, and right back to Java and the second speaker of the day. He is a freelancing senior full-stack developer. He enjoys writing software in languages like Java, Kotlin, TypeScript, and JavaScript, and he loves helping others, so he fits right into our conference with that. Very welcome, Christian.
Hi, thank you for introducing me.
Hi, Christian. Yeah, thanks for joining us. So, Christian, before we start with your talk, would you mind telling the audience and me a bit about what we're going to learn from you today?
Yeah, for sure. So you already talked a little bit about Java 21, and I will try to shine a light on one of the biggest features in there, like the virtual threads. So we will develop an application first in an old-fashioned way, and then we will transform it through the steps until the virtual threads.
Oh, perfect. So you are kind of giving an answer to our last Q&A question, at least for one for one feature.
Yeah.
So I would say, stage is all yours, Christian.
Thank you very much. Yeah, thank you everyone for joining in. So I will try to give you a short introduction to the virtual threads. Of course, it's a huge topic, but I will try to give you a brief introduction about this. So let me show you what we'll talk about today. But first, small introduction about myself. Yeah, my name is Christian, as already mentioned. I've been working in the industry for around 12 years now, started with Java 6, and then 7 years ago, I also switched to more of a full stack role. I'm currently just contracting, so I'm a trainer and frequent speaker. If you'd like to get in contact with me just for any conference, or if you have any questions, just go to my website. You can scan this QR code or go to type.rocks. And there is also my GitHub, where you will find all the code which I will program today. So what we will talk about today? Well, basically, we will go through the topics of, first, we'll create a blocking web application. So like we did earlier in the days with the REST template. And then we will shine a light on how we can change this to reactive and then to Project Loom. So let's start with the blocking one. So many of us started in the early days with blocking, where blocking was still nice. And many of us are still there, because if we think about this, often we have applications which are fast enough with the blocking APIs. You have your REST template and you have just your blocking APIs, and they are just working fine because you don't have that huge throughput you need. So often this is just really how we develop applications still to this day. So let me show you how we do this. So I will go back into IntelliJ here. And what I now can do is, we are in a Spring Boot application. So the first thing we do is, because we are also running with Java 21, we have access to records and something like this. So we will go in there and we will create a new Java class. So the first thing, of course, what we do is with Spring Boot and with Java 21 is we create a WeAreDevelopers controller. And then in here, we say we have a REST controller and we have a request mapping with /API. So to start with the API endpoint. So the next thing we do is we say we have a get mapping here. And we say, well, this is for the speakers. So what we want to do is we want to like fake a request to get all the speakers for this conference. So what we now can do is, let's say we have a collection which we return, and these are speaker. Now we create a record, which is a speaker here, and we say we have a string name like this. So now we say get speakers. And now, of course, what we could do is we could really call an HTTP endpoint somewhere. But because we want to have like a fixed delay to performance test our application, we will create a fake HTTP service. So let's create an auto-wired one, fake HTTP service like this. And let's create this service. So we create this, we tell that this is a service, and we say, okay, we go back into our controller, and what we now say is return fake HTTP service, retrieve speakers blocking, like this. So let's create this function here. And what we now do is, of course, we have to create like a fixed list of speakers. So we say we have our private final list of speaker here. And to make it easy, we will just use an int stream here. Say we have a range of 0 to 10. And for each of them, we will just create a speaker with the speaker and then the index like this. So of course, we could now just return the speakers. But what we really want to do here is we want to add a delay. Why do we want to do this? Because we want to check what happens if there is like a blocking happening in our code. Because this is basically what happens when you use the REST template. You just call, it's for example, an HTTP service, and during this call, the thread is blocked. So we will use thread.sleep, and we will use 1000 milliseconds in this case. So we go back into our application, and what we now can do is we can just start the application. Without any further ado, we can just say, we click on the starting. This now spins up our Tomcat server. And what we now can do is we can switch to JMeter. JMeter basically is an application where you can performance test your application. So what I do here is, we can see here, I have this API./speakers, which I will access. And I do this with 1000 requests concurrently. So there are like 1000 users which access our application at the same time. We have a ramp up period of 10 seconds. So after these initial 10 seconds, we will start to measure the response time. And we'll do this for 20 seconds all in all. So it will take 20 seconds to do. So what we now do is we run this application. The test, we can see here on the top right, it just starts all the threads. And after this, it will send the requests to our endpoint for 10 seconds. So what now happens is, because our Tomcat has a fixed limit of connections, of threads of 200, we will see something interesting in our response time graph. So let me show you the response time. And we can see something interesting happened. It started at around 1 second for the response time, and it went up to around 3.5 seconds. Why is this? Well, let's think about what happens. If we have only 200 threads, but there are 1000 requests happening at the same time, and we have a thread sleep of 1 second, the thread will block, and we have to wait until one thread is available from the thread pool. So this is a problem. And so, but why do we not just use more threads? So let me show you what would happen if you would use more threads. So we go in there in a test class, and let's just create a new test. We say we have a thread test here, and let's just create a list of threads here. And we say we want to have an int stream of 0 to 1000. So let's create 1000 threads. We map this to object, and we then say thread.ofPlatform. Thread of platform is like the same what would happen if you would just call new thread normally. So we call of platform, we say unstarted, and now we say what should happen in this thread. And we say here thread.sleep of 20 seconds, because I want to show you what happens during these 20 seconds of waiting. We surround that with a try catch on user to list. Now we have to start the thread. So we say thread list.for each thread start. And then we want to wait until all the threads are done. So we say threadlist.for. So we have a loop of our threads. And what we now can do is we say thread.join like this, because we want to wait until all the threads are done with their work. All right, so let's go now back in our terminal, and I have a small function here which I can call. It is called count threads from Java. What this does is it just shows how many threads are currently, how many operating system threads are currently running, which come from a Java thread, from a Java process. So currently there are 150. And what happens if I now start this thread test? I just start this, and now they are running in the back. And now if I use count threads, we can see what happened. It created over 1,000 threads. So you can say it's around 1,000 threads which got created from this method. And why is this? Because we can go back into our presentation. Because the problem is that for each platform thread, one operating system thread gets created. So for each normal thread we knew since the early days of Java, one operating system thread gets created. But why is this really that much of a problem? Well, let's go back into IntelliJ and let's change this 1,000 to 1,000,000. Let's rerun this now, and we will see what happens. And we will see some out-of-memory exception pretty soon, because as you can see here, we could not create more threads because we are possibly out of memory. Now, why is this? Because we are using way too much memory to have 1,000,000 threads, because a thread needs around 1 to 2 megabytes of memory, because this is the stack size, the stack frame size, which is needed. So to have like 1,000,000 threads, you would need to have around 1 to 2 terabytes of RAM. So if you want to achieve this, you would have a huge amount of RAM available. And why do you want 1,000,000 threads? Because only if you have 1,000,000 threads, you really can secure a CPU usage of 100%. But where does this 100% and 1,000,000 threads come from? Let me show you. Let's say you have only one thread. Let's say you have a CPU and only one thread running. And you do use this thread to make a request and to make a request to an endpoint and use the response you get from it. The problem here is that the CPU is only then used if you, by preparing the request, when it prepares the request, and when it returns and gets the response and works with the response. But during this time where it waits for input output, the CPU is idling because the thread isn't doing anything. So, and to fix this time, this idling, and use the CPU during this time, you need more threads. But the problem is you can't just create 1,000,000 threads in a normal machine at all. So now we go back to this timeline. We were in the early days, everything was nice, but then we understood, well, we need more threads, but we can't create so many threads, as many threads as we need. So instead of this, the people were thinking, well, maybe we need to go non-blocking. So they switched more over to reactive, and they used this non-blocking approach, this asynchronous programming. So let me show you how the same code would look like in asynchronous programming. So we go back in here into our application, and we will go back here into our controller. Now what we can do in here is we can say we create another get mapping, and we say let's call this speakers async like this. We now will not return a collection immediately, but we will return a completable future. It's important, of course, you could use Project Reactor or another library, but I will use completable future here because this is like the Java way of doing it. And it's much more framework agnostic. So you could always use this in any other framework too, like Helidon or in like Open Liberty, anything. So we now say we want to return a list of speakers, and let's call this get speakers async. Now we of course need to do fake HTTP service, retrieve speakers, and now we can't use the blocking one because we need to have like this asynchronous chain. So we use retrieve speakers async, and we create this method now, which returns a completable future list of speakers. And now, of course, we want to also like fake this delay of one second, because if you use like a web client, for example, in Spring Boot, then this is the same. What happens is like as soon as it sees that the thread will block, it will just release the thread, and you can then just use the thread for something else. So let's implement this. We have a completable future. Let's call supply async. So we wrap this response we have. This is our fake response. And now we can pass something else to it, a so-called delayed executor, where we can say we want to wait 1000 milliseconds until we execute it. So this way we can like fake this asynchronous call to a web API. All right, so the next thing we can do is we can go back into our code and let's just restart our application and run this application and see how this changed the performance of our application. So let's go back into our JMeter here, and we will remove everything we've recorded so far, and let's now access the speakers async endpoint. So we will just run this like this, and it will now again spin up 1000 concurrent requests, concurrent threads, and will then access our async endpoint. This will now take around 10 seconds, and we basically do the same stuff, but we are doing it asynchronously, so we should see a huge speed improvement. So let's check the response time graph. Display the graph, and we can see it took for all the requests always just 1 second, because as soon as this thread was blocked, it would just be used by some other request. So this completable future is much faster than if you would just use the blocking one. And maybe just to a small information about this is, even I think many of you, of course, can't use Java 21, or as already mentioned from the previous speaker, many are still on Java 8, Java 11, or something like this. So, but you can use this with Java 8 or Java 11. So you could use completable future and have a huge speed improvement in your application. But let me show you why maybe it is a little bit more complex to use a completable future or reactive API than using a blocking one. So let's say we want to go a little bit further. Let's say we don't want to get the speakers, but we want to get the talks for each of the speakers. So let's say we have another get mapping here, and we say /talks, and we have now a collection of talk, which we want to return, and let's call this get talks. Now, of course, what we do here is let's create just a new record for a talk. Each talk has a talk name. And now what we want to do here is, first thing we need to do is we just say, okay, we need our speakers. So what we do is we call fake HTTP service retrieve speakers blocking. Now we have the speakers. The next thing we would do is for each of the speakers, we would map over them. And for each of the speakers, we say, okay, we call retrieve talk blocking. And we pass in our speaker and we make a toList. Now this retrieve talk blocking, of course, we have to implement this. So we create this and we say we return a talk like this. Now, the problem with this is of course, let's say we have a thread.sleep in here of 500 milliseconds. And then we return our new talk, and we say talk for speaker, and then we have our speaker.name like this. So the problem here is this is really easy to read. You can read this really easy. Of course, you could change this to parallel stream, but I will come to this back later. So this takes 1 second to run because the speakers API needs 1 second. And this here needs, in our case, 10 times 500 milliseconds because we have 10 speakers. So it takes 5 seconds. So all in all, it takes 6 seconds, even if we do not block because of too many concurrent requests. Then it will take, of course, even longer. But the problem here, of course, still remains that it's extremely slow. So you could change this to parallel stream, but then you would also block even more threads even faster. So, but to make this faster, of course, we can use the completable future API. So we make a get mapping here. We say talks async. We then say we want to return a completable future list of talks. Let's call this get talks async. And now we would just need to do the same as in our blocking example, but instead we have to use the completable future API. So let's get started. The first thing is we have our speakers async. We call our HTTP service with retrieve speakers async. And now, of course, we can't just use retrieve speakers blocking because that way we will like break this completable future chain. So what we now can do is we say return speakers async. And now we have the first thing I don't really like about these asynchronous APIs, because as you can see, we have so many different options to choose from. And that it's extremely hard because to choose the right one, because the problem is that each library or each framework has their own naming conventions. So we use, of course, then apply. So we use this to, as soon as we get our speakers, we then will map these speakers. So what we do is we have our list of completable future talks, and we say we have our futures here. Well, let's call this talk futures. And what we then say is for each of the speakers, we map this. And we say for each of the speaker, we call fake HTTP service retrieve talk async. And we pass in our speaker. So, and then we do a tool list. Now we have to implement this retrieve talk async, of course. And we return here a completable future, which is a talk. Now, what we can do here is we could just copy this retrieve speakers async value and just reuse this here. Instead of 1000 milliseconds, we use 500. And instead of returning the speakers, we return a new talk. And let's call this async talk for speaker. And we have the speaker.name. Now, this is now a list of completable futures of talk. Now, what we want to have is a completable future of a list. And so now what we need to do is we need to say talk futures dot stream dot map, and then we say completable future dot join, because we want to wait until all the completable futures are done, and then use to list. So you maybe see already what I want, where I want to go with this. You have like this nested approach. You have to like map this from a list of completable futures back to talk futures. Of course, you could do this also maybe with a library in other ways. But what I wanted to show you is that this is really not that simple to read code. And this is also what I don't like about reactive. And don't get me wrong, I'm also working like since 7 years as a full stack developer. Prior to that, like 5 years only as backend. But like since 7 years, I work as a full stack developer and also work heavily in the front end with asynchronous stuff, with observables and so on. And I know that sometimes it's necessary, but it's often really hard to write. So it's harder to write this asynchronous code to understand what happens when and what gets triggered by which parts. It's also hard to read because there are so many different frameworks, and it's like your business code is like wrapped in this asynchronous stuff. And also testing is really hard because to test asynchronous stuff, you have to like fake this asynchronous request, this asynchronous context. But the hardest part, in my opinion, is the compatibility, because you have, for example, if you want to have your database also to be reactive, you have to have R2DBC compatible database. You also have many different implementations and frameworks. There are like RxJava, Project Reactor, there is the Completely Futures API, and there are many, many more where you can choose from, and every implementation is a little bit different. So let's go back to the timeline. Now, we can see that, well, we are now in the later days of reactive, so we all found out, well, it's fast, but it's too complex. So, but the people at Java were thinking, well, how can we fix this? And what they did is they created a new project called Project Loom, and they were, prior it was also called like Project Fiber, and they were thinking like, well, what was the problem back then? Why did we switch from blocking to non-blocking, to this reactive stuff? And because they needed more threads, but it was not possible to get more threads because, as already mentioned, it took way too much memory. So, and now they were thinking, well, how many threads do we really want? And as already mentioned, we need around 1 million threads, because this only makes it possible to make the CPU busy for 100% of the time. But why do we need to have this 1 million threads? Why aren't 500 threads good enough? It's because reactive would be much faster if we would not have the ability to use the CPU for 100 times. Because with reactive, you can use your CPU 100 times because you don't have this blocking problem. And they went up with a solution, and the solutions are called virtual threads. Now, what are virtual threads? Simply stated is, virtual threads are like another layer on top of the platform threads, which set up on the class threads, on the class thread. But it's not like a platform thread. It's not like that you have one virtual thread, and for each virtual thread you create an operating system thread. You can have a huge amount of virtual threads because they are extremely cheap. They cost in the magnitude of kilobytes, so in the size of kilobytes, where like the platform threads need like megabytes of memory. So you can have a huge amount of virtual threads, and they work on the platform threads. So let me show you how this works, like in my slides. So let's say you have like a request you want to do to an HTTP server. As soon as somebody hits your endpoint, the virtual thread will get created, because virtual threads will never be pooled. They are like one-time task threads, and then they will get thrown away. So you get your virtual thread gets created. It then looks on a fork join pool of worker threads. So what it does is it checks, okay, here is my pool of worker threads which are available, and I will now connect with one of these threads and will do the work with this. So let's say your request comes in, and you will create a request, then you send the request, and as soon as the virtual thread recognizes that it is blocking, it will tell the JVM to unattach from the worker thread, and the virtual thread will then be moved onto the heap. So during this time, the worker thread is available to do other stuff, like be used for other stuff in the JVM or other stuff by another virtual thread. And as soon as the response, like the input-output result, comes back, there is an operating system signal. The virtual thread will call and say, I want to use some other worker thread to continue my work. So it will then use an available worker thread from the pool. It does not have to be the same one, and it will continue its work. So let me show you how we can do this really easily, and what's the difference between the virtual threads and the platform. So let me go back into our tests here, because as we already were thinking, well, this here did an out of memory error when we call it with off platform. Now, the only thing I change off here is I changed this from off platform, which is just a normal thread, which we knew prior to Java 21, and changed this to off virtual like this. And now let's do something again. Let's check how many threads are currently running. We can see there are like 154 threads running. And now I will start these 1 million virtual threads. Let's start them. And the first thing you will see is you won't get an out of memory exception. And now I use count threads from Java, and we can see it only created around 40 threads. Because, as already mentioned, it does not create 1 million real operating system threads. It only creates around 40, which is like the limit for the worker threads which are configured. And we can see here, it's still only at 196 threads, and now it's done, and it's back to 155. So for a 1 million virtual threads, you only need 40 normal platform, normal Java threads as we knew them. So, but let me show you what really happens under the hood here. So instead of having this thread sleep of 20,000 milliseconds, I say if I is 0, then we want to like spotlight one specific thread. We have the 0 here, and let's say thread.current thread, and system out what the current thread information is. We then say we have a thread.sleep of 20 milliseconds, and let's just do this 2 more times. Now, let me show you something interesting here. Let's start this again, and let's see what the console log will print out. We can see here that we get the virtual thread number 22 each time. So there is the thread itself, the virtual thread is always the same, but it's running on the worker thread 1. Then the next time after the next thread sleep, it runs on worker thread 8 and then on worker thread 6. Well, but why is this? Well, because at this sleep call, the thread blocks and it will unattach and we will be moved to the heap and then will be attached to another worker thread. Now you think, well, how does this virtual thread know this? Let's go into the sleep thread. And now if you check like Java 8, you won't see something like this. You will only see sleep 0 nanos. And why is this? Everywhere in the JDK where threads were used, the team added support for virtual threads. If you would check the pull request, the merge request into the JDK for this virtual thread stuff, it's over 100,000 changes. So everywhere before only normal threads were allowed, now also virtual threads are allowed to be used, and it will be then handled differently. So, but let's now go back into our code. How can you use these virtual threads for your normal daily programming? If you are using Spring Boot 3.2, what you can do, the only thing you have to do is you can go into your application properties, you say spring.threads.virtual.enabled true. That's all. And what this does basically is it sets another executor service for the request handler. So the request handler per default uses this Tomcat, this thread pool. But for virtual threads, you don't want to pool them. So what it does is it creates a new virtual thread for each request to our application. So we have this virtual threads application, and I did change nothing in the code, just this one flag. I restarted. And now let's go back into our JMeter. Let's clear everything up. Let's go into our load request and change this back to speakers. And as you maybe have can remind, this it was that it took like 1 second to start with, but it went up like to 3.5 seconds. So now let's run this and check what happens. We spin up our 1,000 threads. Then we will access with our users our endpoint. This endpoint now will, for each request, create a virtual thread. Then it will do the request, and then it will throw the thread away. So let me show you what the result here is. Let's check the graph, and we can see it's 1 second all the time. And why is this? So there is no like peak in lower response time, because let's think about this. It's really easy basically to understand that when we send this to this retrieve speakers blocking, if you would have a REST template, this would also like block the thread. But we can do this, we do this here manually. We say thread.sleep of 1,000, and this is the only thing that basically happens is the thread sees, oh, I blocked, I will remove myself from the worker is available for something else. So as long as we don't have input output, as long as we don't have CPU heavy stuff happening in here, it's so much faster because the thread will no longer block these worker threads. So now, but let's go and check a little bit, how could we make something else faster too? So let's go back into our controller here. Now, the problem here with our get talks still remains that this will always take 6 seconds. Why? Because even if it will not block anything, if all the requests go through in perfect time, this still takes 6 seconds, because this retrieve talk blocking takes just these 5 seconds to run for all the speakers, and the speakers itself takes also 1 second. Of course, you could use parallel streams here, but it is disencouraged to use virtual threads in combination with parallel streams. This would go a little bit far to explain this in detail, but Java provides another way to use like these to work with loops or with streams by using something called structured task scopes. Structured task scopes are currently in a preview and will be available in Java 22. Sorry. Now, how can we make this much faster and run this in around 1.5 seconds? So the first thing we do is we create a try with resources block. Try with resources, we say we have our scope here, and we create a new structured task scope. You can think about the structured task scope like an executor service. Basically, everything you send to the structured task scope will then be run in its own virtual thread. So we say this is a structured task scope. What kind of elements do we want to send in? We want to retrieve talks, something which retrieves a talk. Now what we say here is, all right, let's just remove this and just move this here inside of our scope. And now what we say is we have here our list of subtasks. And the subtask is of type talk, and we call this, let's call this tasks. And now, of course, this does not work this way because we are here just calling retrieve talk blocking. Now, what we need to do is we need to wrap this inside our scope. We can say scope.fork, and we can pass it a lambda. And what it does basically is it says, listen, scope, create a new virtual thread for this task, do it, and then return and throw the virtual thread away. So now what we can do is, let's make this a little bit more concise here. So what we now can do is we can say, okay, scope.join or scope.join until. Scope.join does nothing else than wait for all the subtasks we send to this scope to finish, either to fail or to succeed. There are 3 states which a subtask can have: unavailable, failed, or success. We'll see this in the example later. So, but we will use join. You can also use join until to wait for a deadline. But we will use join here. And after this, we say return tasks.stream.map, and we will take the subtask.get. We will take the value which is in the subtask and use toList. Now, this is already what we need to do. So let's just make this a little bit more concise by just moving this up here. And now we just restart our application, and we will run this, and we will access this talks endpoint. So let's go back into our JMeter like this. And we will then go into our load request, and we will access /talks like this, just clean everything up, and we will rerun this. So what will now happen is it will send the request, it will resolve the speakers in 1 second, and then it will send all these retrieve talk requests into the scope, and it will run with these virtual threads in a blocking way, but in parallel. So what we now can see, if we go back into our response time graph, if I check the display rate, we can see it's exactly 1.5 seconds because we are running this concurrently. So, but of course, what you can see here now is this looks quite similar, even if not that nested, like this async stuff. The advantage here is, of course, we can reuse our blocking stuff. We don't have to rewrite everything to work with completable future. But of course, we can make this much more concise. Java itself offers like a structured task scope. It offers also shutdown on failure, shutdown on success, so that you only like run as long as it returns something successful, or shut down if there is one failure. But of course, you can create your own structured task scope. So what we do here is, let's create this. Let's just say we have our class, and let's call it collection scope. So what we can do here is we pass in a generic, and we say it extends structured task scope, which also takes like this generic. Now what we can say here is, okay, we want to have a collection here of type T, and this is like our private final collection. And now let's call this collection, and we want this to be like a concurrent collection. So we want to have a new concurrent linked queue, for example. And now each structured task scope allows to override this functional handle complete. So each time a subtask completes, either a successful or has an error, it will call this handle complete method. And the cool part about this is we could also create like a list of errors, and then we collect the errors, and we can also then return them and check the errors themselves. But we now know that this will all work fine. So we say collection add subtask.get. And now what we do here also is, let's create a function, the function which returns our collected results. So let's call this collect results. And what we do here is we say return and collection. But now be careful, we always have to make sure that every subtask is run. So we wait for all the subtasks to be done. So we have to use this .join to wait for all the tasks to be received, and we say ensure owner and joined to be sure that we call joined and that we are the owner of this current object. So, but what can we do now? Well, basically, we go back in here and we can refactor some stuff. We say this is no longer a structured task scope. This is a collection scope of type talk. We can now remove this assignment here. We can even remove this to list. We can now remove this map and this stream we can use for each. We can now remove the scope join. And what we can do instead is we can say scope.collect results. And now we can rerun this, and we will see that it will result in exactly the same result. So I remove this everything, I rerun this, and we'll see that it will be exactly the same result as before. So as you have seen, maybe this is really concise code. It's like 4 lines of code. This collection scope can easily be reused. You could, of course, also make like a talk scope or something else, but it's basically you create it once and you just reuse it. Really easy to understand. It's also, you can use your blocking stuff. So let's go back in here. We can see the response graph. We see 1.5 seconds, still the same as before our refactoring. So now, before we end talk, I want to talk a little bit about thread locals. You can use thread locals exactly the same way as you would use them with normal threads, because virtual threads are just normal threads for you to use. The only difference where you maybe have to be careful is if you have thread locals where you add expensive objects to it, because prior to the virtual threads, you were only using, like, for example, 200 threads, which then will were reused. Virtual threads are in the amounts of millions, and they are not reused. But of course, you can use it exactly as before. You can also use it like to pass around logging context. Everything works as before. What are the restrictions? First one, if you have a synchronized block, in there, the worker thread is pinned on the virtual thread. So they are connected with each other. So to fix this, you could use a so-called reentrant lock instead of a synchronized block. Apache Tomcat had a huge problem with this because they had so many synchronized blocks everywhere in the code, but they switched it out to reentrant locks, and it just works fine because reentrant locks can work with the virtual threads. Second one, native calls. If you call C code, or you call code which has memory, can access the memory itself, then you are also pinned to the virtual thread with the worker thread, because you can't just move memory around if you're using like C code which accesses the address, because that would mess with memory access. And the third one, and this gets overlooked sometimes, is if you have CPU heavy tasks, you don't get a speed improvement, because the virtual threads will then be stuck with the worker thread as long as the CPU is really busy, and it will only unattach as soon as the thread isn't doing anything and is waiting for input output. This is basically the stuff. So let's come to the conclusion. Like, first thing is, the virtual threads really made blocking great again. It's a real alternative to reactive. It's extremely fast. It's also really easy to do a proof of concept, because you don't have to rewrite all your code to completable futures, because you can just use the flag, or in other projects, just use a different executor service, use the new virtual thread executor service. And it's really easy to check if it works for you. You don't have to rewrite everything. And it's also done in the JDK, which I really like. It's not like something which was created from someone else. It's really baked into the JDK. It was taken care of, that the threads still work as before. Really awesome. And as you can see, much less boilerplate code, instead of like, for example, the completable futures API or this asynchronous stuff. Yeah, where are we on the timeline? We are currently at Java 21, a new kid on the block. We don't know what the future will bring to us, but I think with this release, Java really showed once again what an awesome language Java itself is, and that it always has something new to bring to the table. And this will, of course, make it much easier to work with this blocking stuff and make many applications much faster. So the questions will be done later with Bene. So yeah, before we go to the Q&A, I just want to say thank you for all the listeners. You can just go to my website if you'd like to have any questions later after the talk, or if you want to get in contact with me. I really would like to hear from you. And yeah, thank you. And I think we will now go back to the Q&A session. Thank you.
Christian, hello again. Thank you so much for the talk, and thanks for the demo. We always love us some live coding.
Cool. Thank you.
Yes. So, and yeah, as you mentioned already, we got some questions. So let's jump into a quick Q&A, I would say.
Cool.
First question. How does the use of virtual threads impact the scalability of Java applications in scenarios with varying workloads, for example?
Yeah, the cool part about this is that the virtual threads are like these one-shot threads which will get created and then removed. The cool part about this is that it scales really well, because as you maybe think of, you have seen that I have like this 1 million virtual threads, and they only need like 40 worker threads. So it scales really well. For example, it's easy on a normal machine to run like 1,000 platform threads. So you could think of like these 1 million virtual threads only needed like 4 worker threads to be performant. So it scales extremely well with these Java applications, I think, in any scenario. as long as you don't have like this CPU heavy tasks as mentioned, then it isn't really that helpful.
Yeah. Right, but yeah, good to know. Good outlook also for the future for scalability. Next question. As a freelancer, we don't have that often at the live day. So question to you, can you give us some insights on your workday as a freelancer, or also any tips on how to become a freelancer?
Yeah, so it's like I've been working like as freelance like for 2 years now. Prior, I worked like as a full-time employee. And as freelancing, I'm basically doing like contracting work. So basically, it's like the same as you were as if you're like the member of a team. Currently, for example, I'm working at an insurance company. I'm like a full member of their team. The only difference is like I'm like an external source. Like I always like have contracts for like 6 months or a year. But the cool part about this is that you really see many different projects, you see many different companies, and you can always like learn something new from each company. So it's like you can do different stuff. Like the normal freelancing, many know is like that you do like project work for different people maybe at the same time. I myself do like one project, for example, full time, and I really like being part of a team to work with. Like if I would be a normal full-time employee, but I'm like just like have always this contract for 6 months to a year. Yeah.
Okay, but could one say that you are employed project-wise, or is it really like for time frame? So like companies say, hey, we need some additional resources for the next half of a year, something like that.
It really depends. So often there are like projects which that especially in larger companies, it's like a huge. The projects are take a long period of time. For example, a project takes 2 years, but of course there are also things where they say like we need a project for like 3 months or something like this. But I'm from Switzerland, so in Switzerland it's often the case that they really need people to work basically in their team because they don't know how their budget is for the next year or something like this, so that they can say we have one for like a year to help us with anything in there, and then if we have not enough money, then they have to go. It's way harder, of course, for full-time employees. They can't just hire and fire them, like for example in the US.
Like a mercenary.
Yeah.
All right. Thank you for those insights. And let's jump to the next question. Could you elaborate on the problem with using parallel streams?
Yeah, so it's like the parallel streams themselves also use like threads beneath. Like they have also these thread pools underneath it. So it can get messy with which kind of thread is really working with what. Of course, you could absolutely use it with the parallel streams, but if you really want to take full advantage of the virtual threads, then this structured task scope is much more easy to work with because you are then just in this whole context of the virtual threads. But there is like a really good YouTube channel also from Java itself, where they have like a long explanation about these virtual threads and the problem with the parallel streams. I don't have it like to my hand, but I think you can just search in YouTube with the parallel streams, and they really elaborate on this because it's a little bit more complex, and I'm not really sure if I could get it right now in this short amount of time. So I will guide this over to the Java guys.
Yeah, outsourcing, also a good concept.
Yeah, exactly.
All right, thank you so much. And we got another question. Do you also have some experience with debugging problems and solutions when dealing with virtual threads in a testing environment? Anything to be aware of?
This is a really nice question. And the cool part about this is that you should not have any problem with this, especially in comparison with the reactive stuff. I think if you have worked with reactive stuff, then it's really hard to debug this and to find. But the virtual threads are basically the same as you would debug anything with normal threads, because it's really just a normal thread. Maybe if you have seen in my test where I created like this 1 million threads, the list was still a normal thread, a list of threads. So this means that it's like not really any difference, and it's really easy to debug this, especially like because it's like just normal blocking code. Of course, when you send it to the executor service, then it's like, I have to say asynchronous again, because you send it to the executor service and it will then return. But it's like really, really easy, especially in comparison. And I don't really have anything in my mind that you have to be aware of, especially. Not really that much.
All right, thank you. And we got one more question. Are there any limitations when deploying virtual thread-based applications in different GFM environments?
Yeah, it's not that I think of. I think the JDKs I know, which are on 21, all support the virtual threads. And also the cool part about this, what I did not mention, is that also like all the the well-known database drivers all support, the JDBC drivers also support like now the virtual threads. So it should be easy to just switch it on, and you should not see anything bad happening if you deploy it in any JVM environment. So it should really just work out of the box, because they really took care that it is like compatible with the normal thread behavior. Yeah, I think it should be no problem.
All right. And maybe one last question, since it fits your topic a bit more than the last one, about Java 21. What do you think about it so far, and are there any features that are missing?
Yeah, so I'm quite heavily also programming like in Kotlin, and there is still some stuff I really a little bit miss about Java, especially like the stuff like top level functions, so you don't have to wrap everything in a class, or like extension functions, which are just extremely helpful in Kotlin. But I think Java is really, with the 6 months release circles, are moving in a really good direction. They have so much stuff. And I also do like Kotlin talks, and I also compare Java with Kotlin. And each time I do a Kotlin talk, with each new Java release, there is less and less which is only in Kotlin and is not in Java. So it's really cool to see that Java is really coming closer to something like Kotlin or to C#, for example.
Awesome. Happy to see the gap also closing a bit more.
It's closing, exactly.
All right, Christian, you told us you need to leave at 12. I would say we give you 3 more minutes to pack your stuff.
Perfect. Thank you very much.
Thank you so much for joining today and giving us all these very valuable insights. And hopefully see you again on another live day.
Thank you. Bye.
Thanks, Christian. Bye-bye. All right, and we are coming right to the third speaker of the day. He is consultant at VPS Workplace Solutions, also author of 2 books, Domain Storytelling and Domain-Driven Transformation. He lives his passion as coder, coach, and consultant at his job as consultant at VPS Workplace Solutions. Very welcome, Henning.
Hi, thank you, Bene. Sorry.
Hi, Henning.
Thank you, Bene.
Good. Thank you so much for joining us today. So, Henning, before we start with your talk, would you mind sharing a bit about your topic?
Yeah, so what I'm going to talk about today is something that we need in the Java world, but which is in general also on other tech stacks important, because in many situations we build software and then we use it for a time, and then the software is old and then it has to be modernized. And I would think most of the listeners of this day are, like most developers, not working on a greenfield situation, but in a brownfield situation where you already have this big old monolithic piece of software system. And I'm going to talk about how we can transform that, how we can modernize that with the help of DDD. That's why it's called domain-driven transformation.
Okay. Yeah. So sounds like a very valuable topic to lots of our viewers. Then I would say, without stealing any more of your time, the stage is all yours, Henning.
Okay, Bine, thanks a lot. And welcome everybody to this talk on domain-driven transformation. I will try to have an eye on the chat. So if there are questions directly, if there are questions directly during the talk, please post them into the chat and I will try to have a look on that, have an eye on that, and then answer it on the right situation. So domain-driven transformation. I would like to start with a little story to set the place why this is important. And when I was a little boy, my grandmother used to take me by the hand and go down to the port. I live in Hamburg, which is a big port city. And my grandmother and I, we watched the giant ocean steamers rolling in and out. And she showed me the old contour where already my great-grandfather had traded cocoa and coffee. And strolling through the port, you could smell the big wide world. There were ripening bananas from South America, tasty tea from China, sometimes even wild animals from Africa. And in the old days, the ships, they were unloaded by men, by people, so-called stagers, into big warehouses. Warehouses like this here. And the times changed, as we all know, and then the container was invented. Not this Docker stuff, but a big steel box or many big steel boxes. And these containers, they changed seafaring and generally shipping forever. The stagers, the people that filled the warehouses, they lost their jobs and the warehouses were abandoned. And when you look closely, you can see that this warehouse also is abandoned here. There's debris and there's graffiti. And so a whole area in the port was abandoned. And at some point, the Senate of the city said, well, we want to do something with this area. We want to build something new out of this old stuff. And so a plan was made to put a new building on top of the old building and to build a philharmony on this old building. And after the plan was made, well, the building started and it took years and years. And here you can see some pictures of the construction site. And eventually the Philharmonie was built on there, the concert hall. And then also a hotel is in this building. And then one day, well, years later than originally was planned, and 10 times more expensive than was planned, finally, this new concert hall was opened with a big party that you can see here. And now this stands in the port of Hamburg, of my hometown. And still, or let's say again, the whole wide world comes to the warehouse. Singers from China, musicians from Russia, tourists from America and Australia. And what was done with this old warehouse, that is what we want to do with software also. We want to take something old and monolithic, like our warehouse here, and transform it into something new and shiny again that still can be useful for our world. And well, maybe we don't want to be 10 times as expensive as planned for that. So that's what domain-driven transformation is about. And that's what I'm going to talk about the next 45 minutes or so. And who am I? My name is Henning Schwendner. I'm known as the guy with the many kids in the community. And as you heard, I work as a coder, coach, and consultant at WPS. Besides that, when I have the time, I write books. Bene told you that domain-driven transformation, that is the topic of our talk today as well. And the other is domain storytelling. And both are available in German and in English. The domain-driven transformation English edition is currently in the making, will be out in a couple of months. And storytelling, I would like to start with a little story. not about seafaring anymore, but about a more concrete example where we can find old software. So please join me for another story, the story about the Alphorn Auto Leasing Incorporated. And Alphorn Auto Leasing, obviously, what is it that they're doing? Well, they are leasing autos or automobiles or cars. And what is car leasing? Well, if you want to have a car, usually you have to give a big bag of money to the car manufacturer, and then the car manufacturer will give you a car. If you don't have a big bag of money, then the leasing company comes in between. So the leasing company will pay the price for the car to the car manufacturer. The car manufacturer will give you the car, and you, the lessee, now make a monthly payment, the so-called installment to the leasing company. So that is what is called car leasing. And I think we all can well imagine that Alphorn Auto Leasing has a big old legacy system in place, which supports the company with doing their leasing business. And this system is, of course, called Monoliths, or Monoliths A. And Monoliths is about a 20 years or 25 years old, built at the technology of that day. So some old J2EE stuff, EJB 1 or 2, something like that. And the system has become old because it did its work well all these 20, 25 years. But today, well, this old technology doesn't feel so good anymore. So let's take a look at the context that this Monoliths is used in. So you can see here, this is our system Monoliths. This is our company, Alphorn Auto Leasing Inc. And the customer, well, he closes leasing contracts with the salesperson, and the salesperson then is using Monoliths to create and calculate contracts. And then there's also a risk manager who assesses the risk of the contract in the system. So we can see this is an internal system. It's not made for the customers. This is built for the people working in our leasing company, Alphorn. So the system being 25 years old, but still supporting the work very well. The boss says, well, we have to modernize that system. Dear IT department, take the system and bring it into the new world. And the IT system, the IT department does something very clever. They hire a consultant to help them modernize the system. That obviously would be me. And the first thing that the consultant tells Alphorn is, well, before we start with curing our patient, we have to understand which diseases is it that he is suffering from. So first we have to do a diagnosis to see what is it that our patient suffers from. Because different diseases require different treatment, obviously. What are typical diseases that we can find in legacy systems? Well, they have become a big ball of mud. So there is no structure, especially no vertical structuring. Everything is connected to everything else. Then typically legacy system suffers from being an anemic domain model or from not expressing the domain knowledge in a clear way, from not separating domain code from technical code. And then the third disease that we often find is that we have a bad team organization, or a team organization which does not fit into the modern world, which might fit okay-ish to our big ball of mud, to our monolith, but not to the new, more modular system that we want to build today. Those are typical diseases, and what's also typical is that, well, our system suffer from a combination of all of these diseases. What can we do against these diseases? Well, there are different cures that can help us, and there's strategic transformation against the big ball of mud. There's tactical transformation to bring more domain knowledge into the code and to express this domain knowledge better in the code. And there's team organization transformation against the bad team organization. Transformation Well, those are big things, big processes that have to be done. If we look a bit on smaller units, something that we can do in a sprint, then we will see there are refactorings to support all these transformations. So for strategic transformation, there's strategic refactorings, also big refactorings, and then they are built of smaller refactorings. They're so-called tactical refactorings against the big ball of mud. To reform your team, there's socio-technical refactorings, and for tactical transformation, there's tactical refactorings. If you are interested in these kind of refactorings, please have a look at my website here, harshwendner.io/domain-driven refactorings. We will not have the time to look onto all of these, obviously, in 45 minutes, so we will focus on the strategic transformation today. And what is it that is so problematic with big software systems, or what is a key problem for our software system? That is complexity. And when we want to modernize our system, we have to see that we have to deal with this complexity, that we have to control this complexity, and that is key to our modernization. So don't take just my word for it. There are famous quotes here from Bernd, for example, who said the most fundamental problem in software development is complexity. And then Brian Kernighan, controlling complexity is the essence of computer programming. And when we see, well, how do we deal with complexity in software development, then there is the subtitle here, Tackling Complexity in the Heart of Software, of this book here, the blue book, Domain-Driven Design by Eric Evans, which can help us a lot against this complexity and help us modernize the software. And when we look at the strategic part of modernizing the software, when we look onto the strategic transformation, then we want to get rid of our big ball of mud, and we want to have smaller units, smaller modules that can be dealt with easier, which are less error prone. And there are basically 4 steps to be taken when you're doing a strategic transformation. The first step is we want to rediscover the domain and the domain knowledge, regain the domain knowledge. And the second step is we want to model the to-be architecture with that domain knowledge. Then we want to align this to-be architecture with the as-is architecture and see where are the differences, which are the refactorings we have to do. And then the fourth step is do that move. And we want to look at these steps in more detail here, of course. And how do we deal with complexity? Well, there's only one basic way of dealing with complexity, according to Bernd, and that is divide and conquer. So that is why we say, well, we want to take this big ball of mud and make smaller units out of that. And then I would add another way, another basic way of dealing with complexity, and that is avoid it. And what I mean with that, we will see later. For the time being, the important part is here to see we want to focus on the essential complexity and not on the accidental complexity. So we only want to have the essential stuff in our software. So what is the problem with complexity? Well, the problem with complexity is that we have to understand it. So this is our domain. This is all the complexity in the domain. And if we want to build software, we have to understand what's happening in our domain. We have to deal with the complexity in the domain. We have to get it into our brain. And the typical domain is too big to be understood as a whole, and that leads to different kinds of errors. One is the whack-a-mole issue, and the other are the Max and Morris problems. What are whack-a-mole issues? Well, whack-a-mole is a game that you can see here, where you are standing in front of a wooden board, and there's holes in this board, and then out of the hole comes a mole. You have a hammer at your head, and then you hit the mole on his head. And then he comes out of another hole, you have to hit him again. And the mole comes faster and faster, and you have to hit faster and faster. You cannot win that game. You just have to be faster and faster And that is something that is also true in software development, in working with a big old legacy software system. There you have a similar effect. You have this big system and you should make a change to it because you have to implement a user story. And then you go and do something here. And then something up there breaks. That's the mole coming out of another hole. And then you go here and fix it. And then something breaks here. And then you fix that. And maybe it stops eventually. If you're lucky, it stops eventually. That things break. But only because you're lucky, not because you knew in the first place what was going to happen to the system with this change that we were going to make. And that's the important point. The bigger the system gets, the bigger the complexity is, the higher is the probability, the more likely it is that we break something when we make a change to the system. And that's the reason why we want to have small changes here. And the other is that when we work with different teams on the big system, then it's often the case that we stumble upon each other's feet, and that's a problem too. So we want to have clear boundaries that every team can do their own stuff. That is why we want to have these smaller, clearer units, vertical units here. And let's look at these steps to be taken here. Step number 1, domain rediscovery. How is that working? Well, sorry. Well, the first thing that we have to do, and that might be counterintuitive, is if we want to split the monolith, we have to first put it aside. At least mentally, we have to go off the brown field. We have to go onto the green field again. So we have to clean our minds from the solution that is already there and focus on the problem that we want to solve again. So we have to do a mindset switch. We have to get all the technical stuff that we already know out of our heads and go back onto the green field, go back onto the domain understanding and see what is the problem that we want to solve in the business. So that means for us as developers, we have to move on thinking about technology, here the tooth wheel, to thinking about the business, think about the dollars. Because software is never built for itself. Software is always built for a reason. And that reason is we want to support the process of our users. That means we have to understand what our users are doing. That's where collaborative modeling can help us. What is collaborative modeling? Collaborative modeling is a family of methods, a family of tools that help to understand what users, what domain experts are doing. Event storming is one of these methods, which is done with sticky notes. And domain storytelling is another of these methods, which is done with stick figures and arrows. So sticky notes, stick figures, arrows, that all sounds very simple. And yes, that's the idea. We want to have tools that have a low entry barrier because we want to do collaborative modeling. That means we want to model together with our domain experts, with our users. And for that, we need simple and lightweight tools. And that's why these tools have simple annotations like, for example, UML or BPMN. They are not as powerful expression-wise, but they are also not as heavy. So we can easily go into a discussion with our users. And that's what we want to do here. We want to invite the right people. In our case, we would like to invite one of the customers. We would invite a risk manager. We would invite a salesperson and then have a conversation and hear their story, hear what is happening here. And then we will learn, well, it starts with the customer who tells his wish for a car to the salesperson. And the salesperson will then calculate the installment for the contract. Installment, we ask, what's that? Well, we learn installment, that's the monthly payment to be made by the customer. Aha. So we learn something about the domain, we learn domain language. Then the customer will sign the contract and give it back to the salesperson. Then the salesperson tells us, well, I pass on the contracts to the risk manager. And the risk manager says, well, I check the credit rating. That's the risk of the customer. And I calculate the resale value. That's the risk of the car. And then I vote the contract. To vote means say, yes, we want to do this contract, or say, no, the risk is too high for this contract. Let's assume the risk manager votes positively, says yes. Then the salesperson gives the car to the customer. So what you can see here, that's a domain story out of this method, domain storytelling. And you can see we're using a very simple notation. There are only stick figures, the so-called actors, and the other icons, those are the so-called work objects, and then there's one kind of arrow, the activity, and that's it. If you're interested in this collaborative modeling thing, in general, and in domain storytelling in particular, then read my book that I've written together with my colleague Stefan, here, Domain Storytelling. So now with domain stories, or with event storming, or with other collaborative modeling methods, we've understood what is happening in the domain. And with this domain understanding, with this domain knowledge, we can then move on to step number 2, and that is determining the to-be architecture. And that means the to-be architecture and architecture in general is nothing that falls out of the sky. The architecture is something that follows our understanding of the domain. And in this case, especially interesting is the drawing of boundaries. Why is drawing of boundaries interesting? Because we want to have this big monolithic thing and cut it into smaller pieces, right? We want to have smaller modules. So what we do then is we take domain stories which have the right so-called scope. That is, we are coarse-grained to medium-grained, and we want to model pure. And then we actually ask the question, which activities belong together from an actor's perspective? So these are the actors, the stick figures, and these here are the activities. Tails wish for car, calculates the installment, and so on. And here we learn from our domain experts, well, the steps 1, 2, 3, and 8, they belong together, and they form what we call in DDD, in domain-driven design, a subdomain. The whole part of the world that we're building software for is the domain. And in this domain, we want to find subdomains, subparts. And this is the area sales, the subdomain sales, part of the leasing domain as a whole. So we have the whole domain car leasing, and then we have a subdomain sales. And then we find another subdomain here, the steps 5, 6, and 7, where the risk manager is working. That is the subdomain risk assessment. So here you can see how we can draw boundaries in a domain story. And we take these subdomains that we found there and use them for our architecture. So usually it's a good idea to draw another diagram here, because we will not have only one domain story. We'll usually have several domain stories for the different processes, also for different cases. And then it's a good idea to have a more coarse-grained view on the architecture. That's the so-called context map. And in this context map here, we start with a context sales and another context risk assessment. And then more and more context will also follow. And these contexts, these subdomains, well, they help us structurizing the software system now. Because what we are going to do now is take this monolith here and bring vertical structure into that. Split the monolith into one part for sales and one part for risk assessment, and the other subdomains that we are finding here. Okay. And with this to-be architecture, with this idea of, well, that is the goal where I want to go, we can now take our old system and see, well, where do we find this to-be architecture in the system, and where do we not find it? And how can we align these architectures, the as-is architecture and the to-be architecture, with each other? And how can we then move on from the as-is to the to-be? And the first step that we have to do there is we have to determine the as-is architecture. We have to find out how bad is it really. So first we talked to domain experts together with developers. We understood what's happening in the domain. Now we understand what's happening in the system, in the existing system. So we want the developers and architects and whatnot. We want to have the source code and we want to analyze that source code. Typically, it's a good idea to do that together with an architecture analyst, which sometimes uses a tool or depending on the technology, if there's no tool available, then they are working manually. The important point is we want to find out what is the as-is architecture in the source code. So in our example at Alphorn, we already had some architecture with this context view here, the Monoliths system, which is used by the salesperson, the risk manager. And when we go deeper on the C4 model, then the next model would be the container model. And we see Monoliths, well, is built of 3 components. You have 3 containers, a front and a backend and a database. So what we find here is what's called a layered architecture, which is good. There is architecture at least. But if we go deeper, we will see it's only layered architecture, not more. So in the front end, we see there's a leasing servlet and a partner servlet. And they use components here. The leasing service uses components from the back end, the calculator and the contract service and the contract. And these contracts are stored themselves into a database table contracts. So layered architecture means we follow one rule, that is we can access from above the below, but not the other way around. So we see no arrows coming from here to there. That's good. We have a real hierarchy. That is a layered architecture. So we have a horizontal layering, but what we do not have is a vertical structuring. We only have horizontal structuring. And for a system of this size, vertical structuring is something that we necessarily need. So in other words, what we find here is, because we don't have vertical structuring, is what we call a big ball of mud. So we don't have boundaries that are drawn from top to bottom. And we have to bring that into the system again. So now we have an understanding of the as-is architecture. If you are interested on how to get this idea of getting an understanding of what is the as-is architecture, then I could recommend you this book here, Sustainable Software Architecture by my colleague Camunda. You're interested in this architecture analysis and architecture analysis tools topic. So what are we going to do now? We have this layered architecture, we have horizontal architecture, but we don't have vertical architecture. On the other hand, we want vertical architecture. So how do we bring it into the system? Well, let's go even deeper and have a look at only the component backend, where we see whether the calculator and the contract service, they both use the contract. The contract uses the partner, contract service, they also use the partner. If we want to extract our new subdomains that we found, well, where would they be? Let's put this together. So we found the bounded context sales. Where is it in the system? Well, in sales, we need the calculator and we need a contract service. We need the contract, we need the partner. And on the other hand, where is risk assessment? Well, for risk assessment, we would need the partner service and the contract service and contract and partner too. Okay. So we see there are components like the calculator and the partner service. Well, they can easily be put into these components like sales and risk assessment. So calculator comes in sales, partner service comes in risk. But what about this stuff here in the middle? The contract service, the contract, the partner. They are used on both sides. So how can we split that up? Well, maybe your first idea is to draw it out of each other and duplicate it. Okay. Is that really duplication? Well, we have to look deeper. If it is. But this might be a first idea to say, well, in sales, we need all this stuff. In risk assessment, we need all this stuff. So let's have these components twice. So duplication, to understand if this is really duplication, we have to go even one level deeper and go on the class level and go on the field and method level and see, well, where are the boundaries here? So contract, service, and contract, those are classes. We want to find sales and risk assessment, our bounded context here as well. And for that, let's look at these classes. We have the contract service here and the contract there. The contract service has methods sign contract and vote contract. The contract has fields, contract number, signature date, credit rating, voting result, and the contract has getters and setters for that. No real domain logic, no real business logic here. So what we see here is a typical anemic domain model. Not so nice, but well, we can't do anything about it now. Let's go back to what we want to do here, split the thing up. And when we now again see, well, where are our contexts, like sales and risk assessment? Well, we see for sales, we need this sign contract logic. We learned that earlier when we looked into the domain store. So at least we can see here is some domain code, which is good. There's domain names, nice. But it's all mixed up. So in sales, we only need the sign contract, not the vote contract. And then we need the fields contract number and signature date. On the other hand, in risk assessment, we wouldn't need sign contract, we would need vote contract, and we would need the contract number again, and then credit rating and voting result. And now we can see, when we think about the duplication that we were afraid of in the first place, there is not much duplication here. Actually, it's only the contract number, which is the identity of the contract. And well, of course, we need that on both sides. So if we draw this from each other and see, well, let's get rid of the stuff that we don't need, then we get smaller models and different models for sales and risk assessment. On both sides, we have classes, contract, service, and contract, here and here, here and here. But you can see the logic inside, the fields inside are different. So let's clean this up a bit. This is the goal where we want to go. This is our goal architecture. See, well, for every subdomain, for every bounded context that we found, we want to build its own model. That is the idea of strategic design of DDD. If you never have heard about this idea, then you might want to look that up. Strategic design, very interesting. One of the bases also for microservices. Several models, smaller models. That's what we want to do here. Okay, so now we know the to-be architecture on an even smaller level. And we also saw the as-is architecture. And yeah, well, we have to do this move here somehow, right? And this is not something that we will do like this. This is something that will take a long time, that will take several sprints, that will usually take not only weeks and months, but which will usually take years if we really want to split our software up. So it makes sense to see what are the steps that we are going to take. And what many teams do is that they have an own backlog for this, the so-called improvement backlog, which is put beside the product backlog. And into this improvement backlog, we put the refactorings that have to be done to help split our system. So in our case, one big refactoring, one strategic refactoring is we want to extract the context sales. And another is we want to extract the context risk assessment. Well, and how do we do that? We want to go deeper. We want to have smaller steps for that. So 1.1 is extract the specialized contract for the context sales and extract the specialized contract service for the context sales. And maybe we want to go even deeper, have even smaller steps. The goal that we want to have here is, like with the product backlog, we want to have things that are sprint ready. These are not user stories. these are refactorings, but still these are product backlog items in the end. And of course, here for the second refactoring, we also want to find out refactorings that have to be done. So with this improvement backlog filled, started with the first idea of the improvement backlog, starting with the first idea of steps that have to be taken. Well, we can then move on to step number 4. The most interesting step, of course, how to do the move now. How can we split up the system? The first thing is we have to plan it. So besides our product backlog, where we have user story A, B, C, and so on, we now have an improvement backlog where we have strategic refactoring 1, and strategic refactoring 2, and then these strategic refactorings are made from tactical refactorings 1.1, 1.2, 1.3, and 2.1 here, and so on. And when we are planning a sprint now, then we start with what we're always doing in a sprint. We plan user stories, which are sprint ready into our sprint backlog, but we don't do this for the whole velocity of our team. So if we say we have 10 story points that we usually can make in one sprint, then we say, for example, well, 7 story points are something that we want to do for user stories. And then there is a base level of 3 points that we are using for the improvements. And we plan some improvement stuff, like here, the strategic refactoring on number 1 with the tactical refactorings 1.1 and 1.2 into the sprint backlog. So we reserve a part in our sprint velocity for the improvement, for the transformation. And here I'm showing it how to do it with Scrum, because many teams work with Scrum, but the same idea, of course, works with Kanban and other ideas as well. So when we're doing Kanban, then we have a work in progress limit, a WIP limit for new requirements for user stories, and a base WIP for the refactorings that we want to do. So now the sprint moves on, and then user story and strategic refactorings, tactical refactorings are done. The strategic refactoring is not done because, well, there's another tactical refactoring back. So now we move on new user stories, new tactical refactorings, and work on, and so on, and so on, and so on. And eventually the improvement backlog is empty or not. Of course, the improvement backlog is also a living thing. And what I'm showing you here is not a waterfall process. We start with the first idea, what the new system should be, and then we take our system that is here and move it into that direction. And then we learn, well, the goal is here, and well, this is what software development is all about. That's why we're doing this in an incremental, iterative way. And this is, of course, true for the product backlog and the improvement backlog as well. So this is the planning part. And if I still have time, then we can have at least a small glimpse on how can we do that, these breaking of the big steps into the small steps here. So we start with Monoliths, right? And then we have planned our small refactorings. On this example, how can it work? Well, this is Monoliths. And now we start with building the new work. And for that, we have to understand, well, in Monoliths, we have this method vote contract, and that is called from somewhere in the code, and a vote contract, the method calls get contract number and set credit rating and set voting result. So when we want to extract the first bounded context, that is the risk assessment context, well, then we start with first building a new empty package or module or a DLL if you are in the .NET world. So we are building a new module, a new bounded context here. This is something that we can already release to production if we want to. We want to have small steps that are viable, that are able to live. And then the next thing is, well, we build an empty class contract service here. Also a step that is viable on its own. And then we take this method here, vote contract, and copy it over to the risk assessment bounded context and release that. Again, this is viable. And that means that vote contract calls get contract number and set credit rating and set voting result. And then we can move on and say, well, vote contract here. Now we delete the body of that method and just forward to the vote contract here risk assessment. And that means, well, these arrows, they will get away. And again, we have we have a state which is this architecture may not be nicer than the architecture that we had before, but they are small steps into the world where it will be nicer. So now we can take this arrow here, or these arrows, and see, well, where is vote contract called, and move on to take all these calling states and call the new method here. And maybe eventually we can get rid of that. And then we can delete that old method here. And now we have carved out the method vote contract here. And we did this step by step, evolutionary in steps, where every small step was able to be delivered and was able to be deployed into production. That's what we want to do here. We want to have very small steps, because always in between, we want to be able to add new functionality, because the user stories we also have to do here. So sign contract, we can change that. Own contract, we can change that. This we would do in the new world. Okay, and then we would move on and see something similar here. Take the contract, start with an empty class, then make a connection from the contract service to that. Here, the contract number, we want to have that here as well. And we don't need that arrow anymore. And then the credit rating and the voting result, and we don't need these arrows here anymore, and we can get rid of them here. And you see, well, now there are no more lines crossing here from the risk assessment directly to that, and that is good. Now we are starting to get a nice architecture with really boundaries that exists here in the middle. Also, you can see here the monolith is starting to shrink, because vote contract, we throw that out. Set credit rating, we threw that out. Set voting result, we threw that out. Not everything is going to be thrown out here. The get contract number, you can see that we have it on both sides. We have duplication there. But we now get slowly into a state where the world is better. And now if we want to make changes to the sales part, then we will still do that in a monolithic system. But when we do changes to the risk assessment, we can do that in the new shiny world here where we have our risk assessment bounded context. That's the goal where we want to go. Have small parts and make these small parts bigger, and more small parts. And maybe eventually we get rid of the old monolith. Or maybe not. It's a journey that we're going on. And the idea is that we very quickly come into a state where the world is already starting to get better. Okay. So what's happening is then something like this here. We remove this stuff, the monolith is smaller here. So the next thing that we could do then is also tactical design. I already told you, well, this contract service and this contract that we have here, well, they are anemic, what we call an anemic domain model. The domain knowledge is not modeled well in this thing. It's also something that's interesting, but I'm sorry, we don't have the time for that now. Also the team organizational stuff. We don't have the time to go into that. So, oh, sorry, I want to come to the conclusion to stay in time. And that is, well, in 45 minutes, it is a bit like in this old meme here, how to draw an owl. 2 simple steps. Step number 1, draw 2 circles. Step number 2, draw the rest of the damn owl. So I think I've shown you step number 1 and maybe 1A, 1B, 1C, but if you want to do it in real life, well, this is a first idea of how you can do it. So if you got interested in this stuff, then, well, read my other book here, Domain-Driven Transformation. Or look into the catalog of the refactorings. They will help you do all this stuff. And it's important to take one lesson here, and that is monolith transformation is possible. And it is hard. But only because it's hard, don't give up. It's important to keep the stamina. It's important to hold your breath. It's important to see it's not a sprint, it's a marathon that we're going to do here. It's a journey that we're going on. So monolith transformation is possible and it's hard. There are many mistakes to be made. And well, the biggest mistake that you don't want to do is go on the journey alone. It's a better idea to take somebody with you on the journey who already did most of the mistakes, and you can learn from them. Okay, and with advertisement for myself, I would also make advertisement for something good, and that is, please consider making a blood donation. After the pandemics, the blood banks are still dried out. Your blood is needed. So please consider going to your nearest blood bank, and you don't have to look onto your arms. You don't have to see when they put the needle here, and it doesn't hurt at all. Okay, and with that, I say thank you for your time. This is the end, and I'm open for questions if there are any.
Henning, hello again. Thank you for the awesome talk, and what a nice closing, I must say.
Thank you.
Also very important topic. So, Henning, as we still have some minutes left, and if we have a few questions, I would say jump into a quick Q&A. Yes. All right. First question. Do you think Arch Unit is reasonable to use?
Yeah. So Arch Unit, for the people that don't know it, what is Arch Unit? That's a tool where you can use your unit testing framework to check if architecture rules are followed. I like that idea very much. And I like that idea so much that I actually have an open source project with a group of colleagues that it can be used by Arch Unit. So if you want to have a look at X molecules, maybe I can write that into the chat. xmolecules.org.
Yeah, we will share this with the audience.
I think the chat is not working for me. Okay, then I write it into the chat here, and maybe you can share that. xmolecules.org, that's a family of small libraries where you can annotate your code and say this part of the code follows the following patterns. Or when we think of this DDD thing, we can say, well, this is a value object, and that is that is an entity. And then there are rules for Arch Unit which can help check these rules. Do we want to do that when transforming the monolith? Yes, this can help us enforcing the rules that we want to bring into the monolith. Mm-hmm. Typically, that's something that we want to do on the newer parts or on the carved out parts, and not so much in the monolith, because it's harder to bring it into the monolith inside.
All right. Thanks for the explanation. Let's go to the next question. Do you have any tips or tools automation for the domain-driven transformation process when dealing with large legacy code base?
Yeah. So there are tools for this analysis part. I mentioned the book of my colleague Carola, my co-author on domain-driven transformation, where she wrote this book, Sustainable Software Architecture, where she shows different tools to make this analysis. One example is the Sonar graph. Those are tools that can help with the analysis. When it comes to the real transformation, when it comes to reworking the system, then this is typically something that we want to do manually, that we are doing by hand, because so many things can happen there and can be destroyed. That said, it all depends. It depends on the situation that you're in. That's what I started the talk with. We have to see what are the diseases that our patient is suffering from. And one thing that in many situations happen is that we not only have an old architecture, but that we also have old technologies and old programming languages, and that we even want to change that a bit. And then maybe we want to have some automation that is there. But there are no general tools that can be used for that automation. That's something that we want to have a look on your concrete situation.
All right. Thanks also for this answer. Next question. What metrics or key performance indicators do you recommend tracking?
Good question. And probably I have to think about that more. So thank you for that. So what I'm typically in the situation as a consultant, as someone who comes from the outside and who is there for providing an outside view and help people first to get an understanding of how to do it and then help people to stay on track. And for me, the most important thing to track here is the improvement backlog, is to see what are the measures that we want to take here. And those, of course, can be put down into numbers, and then you can build KPIs on that. If you really need that, well, I would say that depends on the organization that you're in. So this transformation thing is less about measuring, but more about doing. And this doing, that on this doing part belongs that it's important that the people that are working on this are convinced that it's a good idea that we are working on. I didn't have the time to go into that too deep in the talk, but it's usually the pain has to be at a certain level that you really start with this kind of transformation, because before that people think, well, it's okay enough, isn't it? And that's why typically this transformation stuff starts only after a long time after already the system has become big. I'm not too happy about that, because it's, of course, much harder to do that when we already have a big system. But that is what I see out there.
All right. Thank you, Henning. Next question. Do you have any tips if the team is distributed? Are there specific communication strategies that you find effective during this transformation process?
Yeah. Another topic that I didn't have the time to talk about in details is this team transformation thing. So what I showed you is we want to have vertical units here, like the sales and risk management. And what we also want to achieve with these vertical units is that we can give these vertical units to different teams, so that we can say, well, this is Team Skywalker that gets sales, and that is Team Chewbacca that gets risk assessment. So, and we want teams to be able to do anything in one bounded context that they have to do. That's why these boundaries are so important. And when it comes to team distribution, this can mean that we say, well, we want to have, when we have 2 or 3 different places where we have teams, then say, well, we build local teams, and this local team is Team Chewbacca, and that takes care of sales. So then we have a strong connection between the people there, and the distribution can be the boundary that we're using there. Or if this doesn't work because we have different knowledge on the different places that we need, then it's also important, especially when we're distributed, that we do not have communication to too many other people, and that's why we want to have teams that are small, that we want to have teams that are these typical 2 pizza teams, these typical cross-functional teams, agile teams that are 7 ± 2 people, but not more here. And such a team is the owner of a bounded context. And inside of a team, we want to have high cohesion. We want to have a lot of communication outside the teams to other teams. We want that the communication doesn't have to be very high. That's why we want to draw these boundaries. That's why we want to have smaller interfaces there as well.
Mm-hmm. But thank you, Henning, and thank you also for the Star Wars references. Those always work. All right.
But the alternative are Harry Potter references. So
it would work also. I mean, we have Star Wars spaceships. Do we have something from Harry Potter here? I'm afraid not. We will fetch something until your next talk. Then we can do the Harry Potter references. All right. And we got another question. Do you have an opinion on SonarQube?
Yeah, tools like SonarQube, that is dashboard tools, that's often a good idea. So when maybe that's and part of the answer that for the question that we have, what about tools for automation during the process? SonarQube is one of the tools that we can use there as well. And then SonarQube can also see what ArcUnit is doing and where X molecules is. So yes, that's often a good idea to track that.
Mm-hmm. Thanks for this answer as well. Let's jump to the next question. Are subdomains typically discovered by looking at them from an actor's perspective?
The short answer is yes. And the longer answer is you are saying important things here. The first important thing is that you are writing that we discover subdomains. So subdomains are not something that we build. That's not construction. That is something that we discover. That's analysis. And we use this understanding, we use this discovery for construction. And that's what we do in the software. When we build different modules, these bounded contexts that I was talking about, that's something that we build. And that's why it's called domain-driven design, because the architecture is driven by the architecture. The architecture is driven by the understanding of the domain. And that's why we discover them by looking at them from an actor's perspective, yes. And we also want to talk to the people that are these actors. That is something that we have to work out together with our domain experts. It's not something that we do on our own, we technical people. We have to find that out together with our domain experts.
Right. Thanks for clarifying that. Another question. Are there specific tools or practices you recommend for code analysis, refactoring, or ensuring code quality during the transformation?
Mm-hmm. Yeah, this, we had a similar similar question earlier. So again, Sonar graph is something that helps for code analysis. Refactoring, of course, the IDE refactorings, IntelliJ, and so on are things that can help here a lot. And what we want to do is break the big refactorings into small refactorings. That's what I was trying to say with these. We start with strategic refactorings, and then we go down to tactical refactorings, and then we can use the refactorings of the IDE that help us split this stuff up. That said, this works only to a certain point, and we can automate some of the things, but there will always be manual steps here. And especially when it comes to the database refactoring, which we also want to do. Of course, if we fully want to split our monolith, then it isn't enough to take only the domain model, but we also want to split the data model. and have several data models there. There is a lot of stuff where you need a thinking mind that a machine cannot do alone.
Yeah, gladfully that the machines are not taking over yet. All right, and we got one last question for you, Henning. What tool would you recommend for monitoring? Currently, we're using Prometheus.
Yeah. So again, for me, the monitoring is only partly about tools. It's important to see there again. This is something that we want to do to help us humans, and you can measure that only to a certain point. And the important part is to see and to ask the question again at least every sprint: are we still moving into the right direction? And the monitoring has to be done by people and see, well, did it help the carve out that we just did, and did the steps help into the direction of the carve out that we are just using, that we just did? That's the important part.
All right. Then Henning, I would say thank you so much for the talk. Thank you for the Q&A. You really shed some light on some very important topics, I think, and hopefully see you soon on another live day.
Bene, thanks a lot,
Henning,
for your moderation.
Bye-bye.
Bye. Thank
you. Bye. All right. And we jump right to the next speaker of the day. He's OpenJDK developer at SAP SE, works on many open source contributions and also his blog. And since 2023, he's touring Java user groups and conferences all across Europe as a speaker, that is. Very welcome, Johannes.
Hi there. Hi from Karlsruhe.
From Karlsruhe.
Yeah, from the lovely town in the midst of the snow. Formerly known for the Bundesverfassungsgericht for the Germans here. But no, I'm just from my lovely home office and happy to talk to you about debugging.
Bundesverfassungsgericht, what a beautiful German word. Yeah, Johannes, thank you so much for joining from Karlsruhe. Would you mind, before we start with your talk, sharing a bit about your topic? What we can expect from your talk today?
So this topic came out of my frustrations of not finding any information on how debugging works under the hood in the OpenJDK, also in the Java world, and so I tried to shed a bit of light on this topic, and I'll also show you a bit some of the hidden features that modern Java debugging has, and tell you how these are implemented. So you get some useful knowledge and learn a bit geeky stuff about debugging along the way.
Geeky stuff sounds very intriguing. So I would say, Johannes, without further ado, the stage is all yours.
Thank you. As I said, I'll be talking about debugging in the following few minutes. I'm Johannes Bechberger, as you already heard, and I'll start with a simple example. So when we talk about debugging, we usually don't talk about MOFs, which is probably one of the first found computer bugs. But what we're talking about are software problems that we have in our software. And Skadaiska wrote a couple of years back, if debugging is the process of removing software bugs, then programming must be the process of putting them in. And as many of you, and also as I do, probably write a lot of code, we're also putting a lot of bugs in them. And here for this example that we'll keep using in the following talk, is my line counter, and it's essentially a simple application that should count my lines. It has two options. You can either count the lines or count the code line, so excluding empty lines. But here in this example, we would expect that when we run it on our own application on line counter Java, that it outputs 36 because that's the amount of lines there. The problem is, actually, our program outputs a nice little stack trace that we get from Java once in a while because we have an exception, and it tells us that there's no such file lines. And so what we do, we'll look at the code. And when we look at the code, we can look at the main method, we can look at the count lines and the count line method, and showed it to you shortly because that's the idea in this talk, that you use debuggers, because debuggers come to your help. They help you discover why a problem is there. And here, when we go into the debugger, we put we put a breakpoint at a line where the exception said that there's something wrong, and then we are at a line, and then we see that we're getting the wrong file. So we step over and we see that as a file we get code lines or lines, and this is wrong, so we just picked the wrong argument. And that's easy to see with a debugger, and that's where they help. And they, of course, help with many more things. In the following, I'll be showing you many UI examples using IntelliJ, just because that's my daily driver. But of course, most of the examples, most of the things behind it also work for other IDEs like Eclipse. So why should you debug? There are essentially 6 reasons, and that's from Igor Ushakov, someone who works at JetBrains, and he wrote, you want to find and fix bugs. Of course, you want to analyze the code to get an understanding. You can add more logging on the fly. You can change the behavior on the fly to optimize, to try things out, and you can also analyze memory issues and many more things, like on the fly monitoring. But let's discover this in the following. So a question that I typically do when I'm at stage, I'm just usually asking OpenJDK whether there are OpenJDK developers here, because what you see in the following is just my knowledge of how it works. But of course, there are people out there that know slightly more. So many of you have used the debug before, but for those of you that haven't used the debug before, I put a QR link there, and there are some great resources related to IntelliJ, but also to Eclipse. And that's not what I'll give you in the talk. I don't show you how to simply use the debug and how to debug effectively, because go into the net. There are lots of other resources there. But rather, I tell you about things in how to use them, and about the many hidden features. And I think debugging, the skill of debugging, belongs to your toolbox that you open when you have a problem. And there also belongs in the capability to write tests and also to do profiling. And I'm Johannes. As you already know, I usually talk about profiling. That's me at Geek in London in March last year, and I work at the Submachine team. We're the 3rd biggest contributor to the OpenJDK, and we're one of the many great projects at SAP. And so I usually work on stuff related to profiling, but I also work on debugging, fixing stuff there. So now come with me down the rabbit hole, and we'll start with how the broad architecture of your debugging tools is laid out. So general architecture is that you have your IDE with a UI debugger, and this uses Java to call the Java debugging interface. And this Java debugging interface then uses an arcane protocol called JDWP, Java Debug Wire Protocol, to interface with your JVM, and also and this agent then uses JVM TI, like the JVM native interface, to interface with the JVM directly, and then calls the stuff. And this whole architecture here is called the JPDA. I think it stands for Java Platform Debug Architecture. And the cool thing is, with VS Code, it's almost the same, because VS Code has this new Eclipse, an actually Eclipse-based debugging server that translates between the debug adapter protocol of VS Code and in the end JDA and JWP. And so when you're using VS Code and when you're using a debugger, you're actually using Eclipse behind the scenes. So now, after I showed you how the architecture kind of works, I'll show you and talk a bit more about remote debugging. So the cool thing with remote debugging, you can easily use it to connect to remote. You can easily use it to connect to remote JVMs. For example, here you can configure it by the debug configuration, by the Run Debug Configurations tab in IntelliJ, and it tells you also which command line to append to your JVM to start this agent. And what's interesting that typically IntelliJ recommends you to give as an address like *:5005, like the port, but this means that your JVM accepts all incoming connections at port 5005. Usually when you're you want to tailor it down to like really the IP or your system just to prevent some security incidents. So the question is then, of course, are there any differences between remote and non-remote, between remote and non-remote debugging sessions? And I don't know whether it works with the comments, but maybe do any of you have some ideas? Are there differences or aren't there? Okay. Maybe I know whether it's it in comments, but there aren't any differences. It's just the same. You just connect to your JVM directly, and your IntelliJ and your Eclipse hides this from you. So in the following, I'll be talking a bit about some little-known gems that I found together with Thomas Darimond, and I also wrote a blog post on them. That's called on-demand debugging. So the idea is that you can tell the JVM, please start the debugging session, or please wait that someone connects to you, only after you told it on the command line, hey, JVM, please be available for debugging. And that's pretty nice. That saves you a bit of performance, especially when you're waiting a long time till debugging starts. There's also the features of on-exception debugging. So the idea is that when you throw a new exception or a specific exception the first time, then you start a debugging session, which can be quite useful when you debug some exception that happens quite long after your application started. And there are a few other options here. For example, you can tell it to be not in server mode, so to not listen, but to actually go and connect to a debugger, which might be interesting when you are in firewalled applications where you can only like reach out but not reach in. And there's also here the availability of other ways to use, not to go over like sockets, but on Windows to also go over shared memory, which might be a bit better, but yeah, not supported on Linux. And there are also some examples there, and that's very cool. So I can really recommend like checking the JWP help documentation out. But now I want to take you with me on a journey. I went last year onto DevOps Belgium to give a talk on profiling. So it started out in Karlsruhe in the dead of the night, and then I was writing a blog post on the train on the topic of debugging on demand. And yeah, they have a nice train station. Can really recommend going there just for the train station. But yeah, I'm meeting some people loosely related to Java, and I was looking into the JWP agent, and I recognized the bug with on-show with the and I didn't know whether like the exception-related bug was just me not using it correctly. So I was there with Alexei Shibolev and debugging the bug there. And this bug has been there for ages. So it was a mysterious bug, and not this one that it brought like from accidentally with me. But so the idea was with this bug that you had a null pointer exception directly in your debugger. So you have JDB, that's like a command line version of a debugger, and it threw a null pointer exception, and it was quite interesting. So when you're using features that are slightly more obscure in GWP, expect them to sometimes be broken. But the cool thing is with open source, you can just create an issue and you can fix it, and that's what I did. And so you can use on-demand debugging probably and on-show debugging in the newest releases of OpenJDK. And the cool thing is we can, for example, tell to with on-show equals x, EX, to start the debugging session when this exception is thrown, and then we can debug it. It's very nice. Now on to the part where it really gets interesting, onto the part of the Java debug wire protocol. And the idea is that this is like the connection between like your IDE Java process and the JVM calls, and it maps nicely onto JVM TI. So it pretty much tells you what the JVM does. And the idea is here that we focus on this because the upper level, like IntelliJ, what they do is interesting, but the interesting part is like on the connection side, because then you can understand some of the issues of why things like conditional breakpoints might not be the fastest option. So the idea is with JWP, it's a quite arcane protocol. It was developed in the 90s, but you have on the one hand requests that come in. So your IDE requests, for example, a value, and you have events coming in from the JVM side. So your JVM tells, for example, your IDE, hey, the program started, and then you of course have replies that like the JVM tells after a request. And you have lots of these events. And if everything works well, I can show you a demo here. I hope you can see it. Also, the idea is that we have our line count example from before, and I just put some breakpoints in it. And we can use, we can start the JVM and what developed, and that was also one of the reasons why I'm not giving this talk, is that I developed a prototype of a project which can log all JWP messages, and we can start it. We can start the remote debugging session and then just see how many messages they're going through. So you see here that there's like around 3,400 messages going around, and if we like string a step, we can also see that there's some commotions there if we look in, and that's, you see, you get probably the picture that there's lots of things going on. And now back to the talk. So now I want to show you what how it works from the beginning. Like your program starts, you attach to your debugger to your JVM to the beginning of like being at the first breakpoint. So in the beginning, your debugger asks the JVM, hey, please, I'm a debugger too. Here's a handshake. Please start debugging session. And then JVM tells the debugger, hey, yeah, the VM now started. Cool. What's also interesting is that the debugger wants to know how large some of the field types are in the JVM, because this might change. So, for example, like the field IDs that you have in this protocol are related to pointer sizes usually. So when you have 30-bit and 32-bit and 64-bit VMs, this might be different. And then the debugger tells the JVM, hey, please, whenever class is prepared, whenever a class is loaded, please tell it to me, because we have to keep in mind that the debugger and the JVM have to keep some shared state between them. So they have to know which are the available classes, so that the debugger can work with them. And then the debugger asks the JVM, hey, please give me the version, because the debugger doesn't know is this a JVM, a JDK 17, or JDK 21 or so, and thereby also knows like what it can expect from it, also what bytecodes it supports, which is interesting when you're doing hot source code reload. And then the debugger also asks, hey, what are your capabilities? And first, these capabilities were quite minimal. There weren't that many there, but then in JK 1.4 or 1.5, they decided that they need some more, and so they added a couple of them. So essentially, the JVM tells your debugger, hey, can I do early returns? Can I do can the debugger add methods or so? And that's pretty cool, because this enables the JVM to disallow also things. So you could build a JVM that would disallow most of this, and hopefully your debugger can still work with it. So what the debugger then does, it needs to know all classes that are initially loaded, and for each class it gets the kind. So is this a class or an interface? It gets an ID that it can use later to identify a class, the signature that includes name, and also the state. Usually it's asked like, it tells it like, oh, this class is already loaded. And then of course it wants to know which threads are currently running. And also, hey, whenever a new thread is started, please notify me of this. And then the JVM is like, oh, cool. The JVM, the main and the notify threads, they are started here, the thread IDs, and so they have, again, the thread state. And then the JVM tells it, hey, because here in this example, we're loading a program from a file. I prepared a URL class per file loader class. So that's the first class that's actually loaded. And then it tells the debug, hey, I also prepared like the line counter class. And then what the debugger usually does when it gets a new class, it obtains some information. For example, it wants, in our example, because we're looking into these methods, know how the methods look like, how like the lines are mapped to the bytecode, so it can obtain information on where you're located, because the JVM usually only learns about bytecode index. So the JVM knows I'm currently standing at bytecode index Y, but the debugger wants to show you, hey, you're currently at a certain line, so you need this information. And also it's helpful for a debugger to know where this class is located, and much more. You saw there are many more things that it can ask. And then we also already, you saw in my example, we can set a breakpoint, of course, before we're starting the application. And so that's what we're doing here. The debugger tells the JVM, hey, please set a breakpoint. And the cool thing is here, the JVM supports breakpoints. There are other runtimes, for example, Python, that don't really support breakpoints. So that's quite interesting. And it's like a debugging interface that doesn't understand breakpoints is possible, and it has its uses, but the JVM directly supports the concept of breakpoints, which makes implementing debuggers easier and faster, because the JVM can optimize for the breakpoint usage. And yeah, then the debugger finished with the setup, and it tells the JVM, hey, please resume and please run the actual program. And then when the JVM hit the breakpoint, it tells the debugger, hey, I've hit this breakpoint with this certain ID in this thread and is this location. And that's pretty nice. Debugger can then pop up the view and show you the values. And then the debugger asks, hey, please, what's your current state? And then when it's finished, when the person clicking on like this, please go further in the program's execution, then the debugger tells the JVM, please resume. And this repeats essentially. And then there will be a time when the VM dies. So then there's the VM dev event where the JVM tells the debugger, I'm about to die, and I'm about to close the connection. And that's all. That's from the beginning to the end, from the birth and the death of a program. And there are many, many, many commands available. I've shown you here a small selection of commands. There are around 95 in JDK 20. They're always coming. Every new release, there are a few more coming in. If you're interested, you can go to the protocol website and look them up. So the question is then that I asked, so hey, we're seeing that like the debugger, when the session ends, the JVM dies, but does the JVM have to die to finish a debugging session? So the question is, who killed the JVM? And the JVM either dies on its own, of course, like when you call system.exit in your JVM application and the JVM dies, or the debugger can also tell the JVM, hey, please exit, please die. So the question then for me was, can we reattach a debugger? And that's possible. So in Eclipse, there are two ways to terminate the debugging session. One is you can terminate it with like this square box, or you can just disconnect and the JVM runs further and you can reconnect. That's quite nice. In IntelliJ, that's a slightly harder. There's the stop which kills which kills the session, but by default, there's no real way to exit the debugging session without killing the JVM. So, but when you close this debugging tab, then it asks you like, hey, the process remote here in this example, because it's a remote debugging run, is running. Do you want to terminate it? And if you click disconnect, and terminate, it all terminates. That's one of the few places where I found that Eclipse has a nicer UI than IntelliJ. So if you click once in a while, don't ask again, and just click on terminate disconnect. Yeah, you might not want to do this because this makes terminating and disconnecting your JVM application slightly harder. So after I've shown you like the concepts of what remote debugging is and also on-demand debugging, now onto a feature that many of you probably use every day, and that's breakpoints, and especially conditional breakpoints. Because the idea is here, maybe our application has a bug and we want to see in the way it counts lines, and then we click somewhere and be like, oh, I want to go into this loop here and break whenever a line contains a comment. And so we can do it here in the IntelliJ. We just right-click on the breakpoint line, and then we can tell, please execute this condition and only break when this condition is met. So the question is then, are there any performance problems? And of course, if I'm asking this way, yeah, they are. So the problem is the JVM doesn't have conditional breakpoints. It doesn't have support for conditional breakpoints, kind of. So the thing is, from early on, with the breakpoints, when you set a breakpoint, you can also give JWP an expression ID, and that's like your condition. But the problem is, it's since like the 90s declared as for the future, and the expression ID type is nowhere defined, so you cannot actually create an expression. That's quite a pity. So how do JVMs then support it? So breakpoints are emulated using breakpoints and an evaluation on the client side, on your debugger side. So how it essentially works, where we're going again, we're starting our debugging session with the same check with everything before, and I assume here that we have set a breakpoint with a condition called line that contains // and so what debugger does, it does a breakpoint at this line and tells the JVM, hey, please do, and then it tells the JVM to resume, and the JVM then hits the breakpoint first time and is like, hey, I suspend, hey, debugger, take over. The debugger then gets the value of the line. For example, here, the first line of our file is import java.io.exception. And then the debugger tells the JVM, hey, please create a string object with the // and JVM responds. And then the debugger wants to call this .contains method, but it doesn't know all the methods of string, so it has to ask the JVM, hey, please, what are the methods of string again, and what are the specific method IDs? Because, of course, we know what that the method contains exists, but we don't know what the current method ID is, so the debugger asks the JVM, hey, please give it to me, and then it tells the JVM, please invoke the contains method using like the line and the other string object, and then it's like, yeah, the line doesn't contain it. It's the first line with import. It doesn't contain the // so not great. But hey, resume, and then we're on another time. The invoke contains method returns false, and then again, we get the suspend event when the next time the JVM hits a breakpoint. We check it again, we resume, we check it again, we resume, and then we're getting to a line eventually that contains the // We're also creating the / string again and everything, and we're invoking the contains method, and it returns true, and we like, yay, we can finally like get all the proper information to show this small debug information when you're to properly hold. So conditional breakpoints are quite expensive because they are unlimited. This also kind of explains the many breakpoint options that you have in IDEs like IntelliJ, that you can suspend. So do you want to suspend the breakpoint? Do you want to suspend the whole application or the threads, because that's like modeled with on JWP, but also whether it's enabled or not. So should it be really evaluated, and whether to suspend it all. And there are many more options, and these work because the JVM at every breakpoint is suspended, and the debugger has full control, can execute like arbitrary code in your JVM, and so none of this has to be supported directly by your JVM, so it can be done in debugging, which is pretty cool for IDE developers because they can add new features without modifying JVM, but of course it's largely slower. Of course, you have these things also in Eclipse. And so probably the next question is, how are watchers and eval expression implemented? And they implement the same. It's the same thing. When you evaluate an expression, you're evaluating them essentially on you're executing the program essentially in your IDE, but calling back for every method for every value access to the JVM. And the reason for this is that it's all terrible and old. So to quote an anonymous Java architect, JVMTI, so the API is wrapped by JWP. It's a terrible API. We should get rid of it as much as possible. And that's one reason. It's an old protocol. Yeah, it works. It's good enough, but it has this problem. And conditional breakpoints are complex, and especially slow with large conditions because of this. Because we don't have proper support. So, of course, I asked myself, so how could I improve it? So I came up with one, and that's the tunnel that you saw before in my demo. So my idea was currently the debugger is asking like all the time, like, hey, please get the value of X, and then it's asking through JWP, your application, please get your JVM, get X, and then returns, and then debugger wants to know Y. So for example, the debugger is computing X plus Y, then it asks Y, and it goes back and forth, and you have latency and everything around, and that's not that great. But so I tried with an approach to implement a prefetching tunnel. So essentially, your debugger talks with like one end of my prefetching tunnel, and it asks like get X, and then the tunnel knows, oh, every time the debugger asks for X, it also asks for Y, and this is side effect tree, so I can ask just Y, and it usually don't changes anything in my JVM. So I ask both, get both, and the tunnel asks the JVM both on this side, and so we reduce essentially latency. The problem is, in reality, it's much more complicated than I thought. So this is like a small research project that I did. If you're interested in seeing how such a tunnel would work, so this tunnel synthesizes essentially debugging programs to how latency. You can take a look. It's on GitHub. There's here the QR code, but you can find it when you're searching on GitHub for the JWP tunnel. So that was one of the ideas, but doesn't really work in the end. It's slightly more complex. So then I looked into how VS Code is doing it, and they use the debug adapter protocol. And the cool thing is with the debug adapter protocol, this supports conditions, and that's pretty neat because you can bring the condition evaluation far closer to the JVM because this is evaluated in the endpoint. Sadly, the JVM, so showed you in the beginning, doesn't have DAP support, so you need to use an Eclipse-based adapter that transforms DAP requests into the equivalent JWP requests. But this adapter can be placed close to JVM, so you don't have latency when you're running in the cloud with like with being a couple of 100 kilometers away from your JVM. And so there are other ways, of course, especially if we want to prevent all these JWP requests coming around. And one of them is to just put the whole condition, the more complex condition, into a method, and then this method can be called in like the condition place. And that's pretty handy because then you can use hot swap to change this condition on the fly and reload it, and then it works. But you can also do just embed your condition in the code. So for example, here you ask like if line contains / and then you put there a line that doesn't execute anything really, for example, creating a string or doing some statements, just so you have some bytecodes where you can set a breakpoint on. And this works, that's faster because there's no backend to and from between the JVM and your debugger. Now the question is, of course, what are the implications of setting a breakpoint? I showed you how to like make conditional breakpoints a bit faster, but what are the implications when you set a breakpoint there? And the question is, you probably know that in Java you have a just-in-time compiler, and the idea is that the code is optimized and then compiled to something that's far faster than just interpreting it. So the question is, when you set a breakpoint somewhere, are these methods then interpreted? And that thing is, yes, when you put a breakpoint somewhere, the method is de-optimized. If you don't trust me, I put the GitHub link here on the slide. You can look into the code cache.cpp at line 1425. That tells you that like when you set a breakpoint, you're de-optimized. And skipping these. So when you're doing single stepping, of course, that's the same thing. Single stepping is implemented in a way that works only with interpreted methods. So be aware that when you set a breakpoint in a method that takes a long time or that's slightly more complex, takes a lot of runtime, you want to polyglot-centered breakpoint in there because it prevents optimization and can slow things down. And the question, of course, for me is like, are there any resources on this topic? Like, but no, they aren't. That's sadly the truth. So there's this whole area of how breakpoints are implemented is a field that is of importance, I think, for users, but sadly there's not that many resources. The only resource they found is the resource from 2009 from Apache Harmony, but it's slowly outdated. So still a few minutes left, so I can show you how other features are implemented on the JWP level. For example, hot swap, how the subswap works. Essentially, your debugger, when you click this reload button there in your IDE, and your IDE recompiled your classes and tells reload, essentially your debugger tells the JVM, hey, please redefine these classes, and here is class ID and the new bytecodes on the JVM, and then your debugger has, of course, to update its internal state and ask it for like two methods in the field of these classes. You can also use set-specific values. So the idea is that when we're here in this example and from the beginning, and we know here file should be a different value, it should actually be like path of args1. We can ask the IDE to, hey, please let me set this value, and you can typically give here an expression. And the expression is evaluated as before, like you want to get the visible classes, that's an important thing, and also for like conditional breakpoints, you want to know which classes can be used here. And then it's like before with the evaluation, you get the values of args, you get the value of args1. When you path, you invoke the off method, and then there's a specific request that's the set stack frame value request, and that enables the RDE to set a specific local variable. That's pretty cool, and especially everything that's like directly implemented in the JVM and not emulated is faster than things that the IDE has to emulate. Then there's, of course, the feature of force return. That's a feature that I didn't knew before I started this whole work, is that you can tell your JVM, please force return at a certain point. So here in the IDE, you can click on a frame and tell it to force return, and then you also have to give it a return expression. And how this is implemented is quite simply, you just use a force early return request because the JVM supports it. And you just give it like the return value. Of course, you have to evaluate the return value as before. An interesting question is now, what do you do when you are in like at an exception, like the throw new exception, and then force return? Is the finalized block, are the finalized blocks executed? And the answer is no, they aren't. And that might be a problem. And here for the specifics, the JWP documentation tells you no further instructions are executed in the called method. Specifically, finally blocks are not executed. So whenever you're doing a first return, be sure that you don't have things in the finalized blocks that have to be executed. Therefore, don't use first return that often. It might be problematic. So another way to go go out of frame is you can reset the frame. So you can drop this frame so it restarts this method calls, and here it's the pops frame request. Of course, it doesn't reset the global state, it just resets the local state and calls the method again. Then you can you can force return, but you can also, of course, throw an exception at a certain point. That has the advantage of a first return that when you throw a specific exception, the finally blocks are captured, the finally blocks are executed. The problem is, of course, you have to catch this exception somewhere top, and you can create a runtime instance, for example, a runtime exception instance when you want to throw it. Do it as before, and then you tell the JVM, hey, please stop. And hey, I'm giving you this reference to a throwable object to my exception with which to stop. It's pretty neat. So to conclude with this protocol, you saw that this protocol has many features, and it's pretty cool. But of course, it's a cane. The thing is, I looked into the Python debugging support, and I have to say, it's far better, and the protocol, debugging protocol, is fast and usually fast enough. So yes, it's not that great that conditional breakpoints aren't directly implemented by the JVM, but the advantage is that your debugger can evolve without having to modify the JVM. For example, when Kotlin came onto the scene, your debugger can directly support Kotlin expressions without the JVM knowing what Kotlin is. That's very cool. If you want to know more about Python debugging, you can look into my talk on Python debugging that I gave at the PyData user group in November. And I've also written a blog series on this because it's interesting. There are a lot of similarities between Python and Java and a lot of dissimilarities. And that's interesting to see how different languages implement it differently. And the cool thing also with like the Java version is it allows so many things directly in the JVM. So I think it's great that we have it, and it's one of the cool things of the Java community that, yes, some of the tools are old, but still there are many cool people working on them that really know what they're doing. And to finish here, I want to say that like debugging should belong to your toolbox. You should look into debugging, maybe look also into on-demand debugging, into the different features that your debugger already has, and learn how to use it, as well as you should learn the ability to write proper unit tests or to do some profiling. And keep in mind, say no to complex breakpoints and keep away from accessing stepping and remote debugging. Might hurt you. So that was my talk. I'm at Paradigm Nerd on Twitter. You find me on GitHub and Mastodon as Paradigm Nerd. I write a blog post every 2 weeks or so on mostlynodeless.de. You find my team at submachine.io. And when you want to hear more of me, you can come, for example, to JavaLand, where I'll be giving an extended version of this talk, or go to Canada and get a version of this talk. Yeah, so if you want to travel, there's a nice conference in Canada, but whatever. So thanks for being at my talk, and I'll hope to see you at some of the next conferences.
Hello again, Johannes. Thanks so much for the talk. All right, and we got some questions in, and let's start right away with the Q&A, I would say. Yeah, take a big sip before that. All right. First question: on which site condition line.contains will be executed during remote debug? On your debug client or JVM side?
On the condition is exit. So so as I showed you before, I think I can probably I can probably go there back again. So the idea is too many slides, so like 190 slides in this thing. So the idea is that these conditions are actually implemented when we see it here. The conditions are so the methods are invoked on your JVM side, because like the debugger can't invoke methods on the code because it it knows enough. For example, here with string.contains, it has the same implementation probably on the debug side as on the JVM, but it usually asks the JVM, hey, please invoke the method, but it can't ask the JVM more complex things. So essentially, you have a local interpreter that can only look at variables, and for everything more complex has to act like the JVM for the things like, hey, call a method, get me this local variable, start with this local variable. So to answer your question, it's partly evaluated on both sides. The cool thing is with JVM related with Java compared to other runtimes is that Java is platform independent. So when your debugger does a simple computation like a plus, like 1 + 2, it has the same semantics as your JVM, and that's cool. So you can use this to do some load computations, but most of the computations are done on the JVM. I hope this answers your question.
I'm sure it will. Thank you for that. Next question, I would say we just leave your screen there because maybe
Yes.
you need it again. Next question would be, how do debuggers handle memory inspection and modification during runtime? How do you ensure safety and correctness when modifying the variables?
So the idea is here with memory inspection, you can ask the JVM for like, hey, please give me all instances of a certain type, and like inspect the local variables and also like the instance variables and everything. And the JVM takes care that the types are correct. So you're getting objects, you're creating objects to takes care that the types are the types that are statically defined. But of course, when you, for example, have generics and the JVM doesn't know about, because it like removes the generic information, doesn't know that this like list is a list of string, you can probably in your debugger as easily place not an int, but like place an int in a list of strings. And so you have to be careful what you do in the debugger. So especially with some of these features, you have to be careful because sometimes you have side effects when you creating new values, and also when you're doing memory computations, you might in memory modifications, you might invalidate some of the invariants that the JVM doesn't know about. So yes, take care. But regarding types, the JVM usually checks this.
All right. Thanks for clarifying this, Johannes. And we jump to our next question. How are conditional breakpoints implemented in debuggers? Are there mechanics in place to evaluate and execute the conditions?
Yes. So typically how this is implemented in like the debugging frontend is that the debugger frontend does exactly that's what I showed you here. So when the debug breakpoint is hit, the JVM, your debugger IDE looks into, hey, is there a conditional breakpoint that I have to check first? And then it calls this small interpreter. There's even like really a small interpreter directly in Teltra. You can look it up. It's quite nice. They have a small Java parser that parses your conditional expression and then evaluates it. And yeah, when you want to place a conditional breakpoint, that's easy. I showed it. I showed it here. You can just place it here, and your IDE works with this. Keep in mind that every IDE has to implement their own evaluation, so it might differ from IDE to IDE. How many features they support in there.
Mm-hmm. Makes sense. Thank you, Hannes. And we jump right to the next question. Maybe a silly question. No, there are no silly questions. When debugging Java applications, how does the debugger interact with the JVM?
There are no silly questions. There are only silly. There are only silly answers. So the idea is, I showed you here. The IDE itself interacts with like the Java debug interface that wraps the JWP generation, and then JWP messages are sent over the wire usually, so over a socket. So when you do remote debugging, you see it clearly. You see that you open a socket, you set and communicate essentially via TCP/IP. And then, of course, there's this agent. You can even like write your own debugging agent if you want and implement your own custom protocol, maybe even the protocol that VS Code uses directly, but nobody has done it as far as I know. So it's just a normal agent that you attach to your JVM. The only difference is that this agent is like shipped by default.
All right. Thank you, Johannes. Your answer was also not silly. So, next question. How do debuggers handle exceptions during debugging?
Some just break. So I showed you in the beginning of my talk, I showed you this problem where like you had a null pointer exception occurring on like the JDI level, where the JVM sent an invalid message back to a JVM, and debuggers just like crash and go dark. They are just your IntelliJ just is like, oh, there's something happened that I didn't know. I logged this error somewhere away, but I just stopped the debugging session. There's JDB, the command line debugger that prints you these exceptions, but usually debuggers wanna tackle all expected exceptions or everything that might be happening. For example, when you evaluating some code and these throw some exceptions, the JVM handles these and shows you usually a pop-up. But when there's more complex things that the JVM didn't expect, just usually ends the debugging session because it doesn't make sense to like restart it after you're in an invalid state, a potentially invalid state on the JVM side.
All right. Thank you for clarifying this as well. We got another question. In projects with multiple languages like Java and some native code, how do debuggers handle cross-language debugging?
That's an interesting question. So if I'm honest, I've never dealt with like real cross-platform code. I usually know, okay, this is a bug in the native side or this is a bug in the Java side. So I usually just use two debuggers. But of course, debuggers can work with them. They can, for example, ask JDI for like the Java part and then use GDB to interact with the native part. But then you having two debuggers like interacting, because when the new debugger stops your native JVM running, and then you have the Java debugger not like answering anymore because you stopped the application on like the native level, it might get interesting. So I think it's doable, but maybe VS Code supports it, but usually debuggers only support one language runtime, because not one language, because you can have Kotlin and Java code at the same time, but like one language runtime where they support either native or Java. So maybe there's in the future some debugging coming in. When you know such a debugger that supports this, please send me a mail. It sounds like an interesting project.
All right. Yeah. Thank you. And we got one more question, and a real fitting last question, I would say, because what future trends or features do you expect in debugging tools?
So I think one of the main issues currently with debugging and also with the whole space of profiling and supportability is that Project Loom is slightly dooming over. So the problem is that with many new virtual threads, where you can have applications that have thousands of threads, you have to somehow let the user be able to debug them and to also visualize them, because they can be quite overwhelming when you have so many threads and you have to get the right one. I think there's some developments there where in the next couple of years, people will find ways to visualize and virtual threads, and also of course debugging never stops. So now new companies, there are a couple of them out there, start with proper time reversal debugging, so that you can go back in time. You use snapshotting to say like, oh, I can reply on a program execution, and also to do some kind of in production debugging. But I think it's a field that's quite interesting, and maybe we'll see in the next 5 years where these approaches, they're currently like in small startups, are coming to be. In the C++ world, we already have the reverse debugging, the R debugging, that's open source. But in the open source world, there are not that many large developments in the debugging space, just because the current way debuggers work is good enough. So I think there aren't that many pain points, except like virtual threads, that people want to tackle.
All right. Thank you also for that. Johannes, we still have some time left, but we ran out of questions. So maybe is there anything else you want to share regarding the topic with the audience?
It's great that so many people here listen on this topic on debugging, because I think like many people in the Java world focus on like this flashy, like this machine learning in Java and everything, and virtual threads and this and there. But I think it's really important to keep in mind that in your daily work, you're doing debugging and maybe sometimes a bit of profiling, and you want to keep your skill level there, and just look into what your RDE supports. Test it out with a small sample projects, and don't be afraid to dig a bit deeper and to learn to understand how these things work to make yourself a better debugger.
To make yourself a better developer. What good closing words. Johannes, thank you so much for the talk and also for the Q&A. I think you shed some light on some very cool topics. And yeah, many greetings to Karlsruhe, and see you soon on another live day.
Thanks for having me. See you.
Thanks. Bye. All right. And as also this live day slowly comes to an end, we have one more speaker for you. The final one is Senior Developer Advocate at DataStax. She enjoys helping other developers succeeding, which is also fitting since she's president of the Chicago Java User Group. And with her over 25 years of experience in the field, she certainly knows what she's talking about. Welcome, Mary.
Hello,
Hello.
Benedict, right? Yes, hello. Here is good morning, but good afternoon.
Good morning, Mary. Thank you for getting up for us.
Oh, yes, yeah, no worries at all. Yeah, finally, we're still very cold in Chicago, by the way. We're like, I guess like Fahrenheit is like 1 degree or something. Yeah, when I got up, yeah, 3 degrees Fahrenheit. So I think it's minus 15 Celsius. So
minus
still very cold.
15 Celsius.
Yeah.
All right.
We're very cold
All right.
here. Yeah.
I hope you have heating.
Yes, I do.
Right.
Yeah, it's very cold. But anyway, yeah, thank you. Thanks again for inviting me here. So
yeah, thanks for joining, Mary. And I would say before you start with your talk, would you mind giving us some small insights about your topic?
Sure. Yeah. So as such too, even maybe folks have been listening to me. Last year I was talking about more streaming, but this year actually, I should say, it's the company a couple months ago switching to doing, supporting generative AI. So a lot of my topics too have kind of switched to that. And so I just wanted to do this topic as an introductory, especially for experienced folks, in Java, like yourselves and everybody, and but in a very gentle way, and also introduce to you some of the Java libraries that you can work with, the current ChatGPT and all of these things. So yeah, and then vector database, of course, I almost forgot to mention. So yeah, so that's what it is, and then why vector search is important for ChatGPT. So yeah.
All right, Mary, this sounds very intriguing. And I would say, without further ado, the stages are yours.
Thank you, Benedict. Okay, hello everyone. Welcome so much to my talk. And as I mentioned too, I had to get up early, but really excited because it's been kind of a year, and I'm back. So thank you again for the opportunity. So making sure everybody can see it. I think I check and it's good. Okay, so I'm going to start. So again, this is about vector search. So especially maybe for those of you who are interested, right, who are new and you're experienced folks in many other areas, maybe more enterprise or Java, even embedded or anything, not work with Gen AI. So this is the topic for you as more like a gentle introduction, and also to kind of help you to like a quick intro. So then, you don't need to go and do all the research, and I've done the research for you, and talk about, let's enter the brave new world of generative AI. And specifically too, I want to highlight vector search, like similarity search. I think that should be interesting to a lot of folks here. And okay, here we go. This is the agenda for today. I'll just introduce myself really quickly, but Benedict already did that, so thank you so much. And again, this actually I'll go through some brief background of AI, understand also, the players in this generative AI era, and also wanting to emphasize, no need to worry. Some folks are, have been talking about, AI, generative AI, ChatGPT is going to take over the world. But as I'm, have worked in this longer, I've been working on this for like 5 months or so, I realized that, it's not going to be so easy. Folks think that it's going to take over, right? So no, but let's also take a look at the background. We'll understand the players, and then understand some of the terminologies, GPTs, NLP, LLMs, and all of these things, and then vector database, vector search. And I'll quickly show you a quick demo too of Astra vector search too. And if there's time to, I wanted to show you a Java library that's kind of, it's open source too. And so I wanted to show you those, or at least kind of point you to that direction. And then discuss the benefits and the challenges of this ChatGPT, right? And then also share with you some resources. So first of all, who is Mary? I won't spend too much time. I'm a senior developer advocate at DataStax. And so these are, like, as you can see, this pictorial description. I'm also a Java champion, and also the president of the Chicago Java Users Group. And here are just some of the things that I've worked with in the previous few years. I was previously at IBM for 3.5 years as an advocate. And then these are how you can get a hold of me. And those are like my area of interest too. So this is quickly about me. So thank you. And again, let me start now. I'll start with a brief background of AI. So when I was told to start working my team, right, as kind of shrunk too, and folks get redistributed. But I'm very fortunate, thankful to stay being a developer advocate. And my job too is to share with developers all over the world about technology and what our company has. So anyway, when I, every time too, I think when new things come, we're like trying to understand how to do something. But for me too, I took some time to understand. So I found out too with AI, right, is not, it's not in only the 20th century, but it's as early as 400 to 500 BC. And it was, they were like steam pigeons, and they were powered by steam. So that would be considered the earliest recorded history of artificial intelligence, meaning that, what it is that is they are mechanical, but still they operate on its own without human beings doing things. And it was actually developed and implemented, created by this Greek philosopher called Archytas. So that was kind of interesting for me too. So let's also take a look in the near old times. It's kind of amazing in the industry we're in. Every minute, every year, things that happen even 6 months before was considered old is pretty amazing. So if we kind of look back into the previous century, the 20th century, this is like a timeline that I found is kind of captured quite well the development of the modern artificial intelligence that we're experiencing. So I'd say it's roughly almost 100 years ago or so that became like quite an interesting when there were science fictions that came up, right, in the 1938 to 46, that period, golden age of science fiction. And then Alan Turing, the father of modern computing, he kind of wrote essay book on can machines think, so that's kind of interesting. We want essentially to machines to be able to even think, not just like mechanically do stuff. That's kind of like even the idea at that time was groundbreaking, and people couldn't believe that it's actually happening now. So if you kind of think about it, it's less than 100 years. And even though it's not perfect, but I think certainly too with ChatGPT is quite a disruptive innovation too. So now I won't go through all of these timelines, but if you're interested too, you can go to the link below here, or just wait for me at the end of this presentation. I'll also be sharing my slide deck, and then you can take a look too. I found it fascinating, and even like, for example, the nearest time, if you kind of go near like up to 2000 with this map, is that Deep Blue, the chess machine, right? The chess AI, also an earlier kind of invention at IBM, that actually the chess player, the robot beat, Garry Kasparov at the time. Gary was the chess king of the time, and the machine beat him. That was the IBM Deep Blue. So that was kind of interesting too. So all these are contributing to like what we are today, and then what we are today is going to contribute what will happen in the future, and even in the near future too. I think everything's changing really fast. So let's kind of like stop for a moment and kind of look at this AI. It's basically all about automation. It's basically things that are mechanical, repetitive. We want a machine to do it for us rather than human beings, right? And it's really all about automation. Let's also take a look too into AI, how, high level wise, these conceptual kind of things that we're dealing with today. So I like to kind of set the stage first. Is basically, if you kind of take a look into it, AI is this giant, think of it like an onion, a giant thing that's kind of encompass, right? This whole set of kind of concepts and kind of idea, right? And also like all of the expression in what has been implemented today, essentially too, right? High level is AI that mimics the intelligence or behavior patterns of human beings or any other living entity too. That's artificial because it's not man-made. It's not like, I shouldn't say man-made, but it is man-made. But it's kind of not something that that isn't like just born out of it, right? That's the AI. And then if you peel the onion too, it's basically, that's the next layer is basically machine learning. So AI and machine learning are not exactly the same, but we like to kind of lump them together because it is very true. It is one kind of within each other. It's machine learning. So machine learning then is basically, you narrow it down, is basically the techniques, by which the computer can then learn and, essentially from the learning is mimicking human behavior and, of patterns of things like that. So that's machine learning. And also too, the thing with machine learning is that basically you don't even need to consciously kind of train the machine. You're letting the machine train itself by learning from the data. And this approach, is basically for training the model from data sets, right? That's what like machine learning is. And that's what like LLMs are kind of derived from in that. However, too, the thing is, if it just learns, it's probably not going to figure things out. So what really makes a magic click is basically deep learning that involves, the neural machine. The machine learning is basically based on how our brains think, our own kind of neurons, so there's been study research showing to see how actually our brain works. So deep learning gets into this core of it all. So I have another slides too later that shows further kind of inside this deep learning kind of core of this all. But so let's then take a really quick look at the generative AI, this era. So, and I'd like to also comment too, and I feel the more I work on it, some folks have kind of commented that, well, Gen AI is going to be like just a fad, right? Something that, it's fun, let's take a look into it, and it won't last. And some people even compare it with blockchain, with all of the Bitcoin, all of these technology, the cryptocurrency. But to me, though, the more I work on it, Gen AI is a bit more encompassing, because let me tell you, right? So what is generative AI? If you kind of take a look into it, it's basically too within this deep learning space too. It's a disruptive field in AI. Why is it disruptive? Because as we all know, we've been working with traditional machines and all of these things, and every time, right, we need the machine to do some work for us. We would always need to provide it with some form of input. But as we have done things, since the beginning of computing time, we always have to provide an input in a very machine-oriented way, meaning that, even like simple things like a command line kind of a command, right? So we have to kind of follow rules, and each programs are different and all of these things. And very much so too, if you talk to someone, you wouldn't be talking the same way like you program a machine, or kind of using command line to do it. You might be saying that, okay, run this Java program. You use like Java, and then the name of the class, and then you pass parameters. You have to maybe use some flags to say, dash param1 something, dash param2 something. So that's kind of more like the machine way, right? That's just only one way. There could be other ways too, right? But essentially too, we do need to provide input to the machine. Whereas with generative AI is that, as we all know, the difference is that it is what is being called prompt, right? You need to prompt the machine, the bot, to do things for you. And the prompt is amazing because there's no more for, the need for you to kind of conform to this machine-oriented way of addressing the machine or kind of sending a question over. As we all know, you just type in, like we talk to another person. Hey, how do I do this? And even last night I was looking at some idea and I said, I don't know how to do it. I quickly sent to ChatGPT, right, at OpenAI. I say, can you write me some code that would show me how I can set up a Kafka topic? And it actually talks about it, immediately comes back, within a few seconds, and kind of telling you all of these things, which is really nice. So it's really disruptive in that sense, and basically has the potential way of changing our whole approach to how do we create content, how do we consume content like that. So it's very disruptive in that sense. And it uses a combination of machine learning and deep learning to produce the contents. And also too, one thing I want to point out is that generative AI is supposed to, it's not all brand new. I say AI, right? As such, too, right before this, I'd say the AI that's been, common at companies are using more predictive AI. So predictive tends to be, yes, you still analyze all of the data, but the difference is that then you are still using, there's no such thing as kind of like the natural language kind of way of prompts, right? And not only that, too, predictive AI is basically dealing with topics such as, show some prediction about the weather pattern, for example. Show me pattern predicted next year, something like that. So based on some data, it will kind of create, find answers and then generate the answers for you. Very much, kind of restricted to some time limit too. So in other words too, like for example, weather forecast, business and marketing forecast, all of these tends to be, has a time limit to it. Whereas for Gen AI, the difference is that it tends to be more on the creative side. Now it actually can write code for us, right? It can write a blog post, design a fashion, some kind of dress, a fashion for us. And also other things like, go find me something, or I'm looking for a house, I need a 4-bedroom house with 2 bathrooms and a garage, something like that. And it will go and search for those answers for you. It can even come back, right, with some pictures for you and videos and things like that. So that's kind of like the very disruptive side of things. Okay, so let me kind of get a bit more into the current Gen AI, kind of a bit of a history. So so what is making it happen is basically not only the neural network side, right? And there's also the input, the natural language side. So since, I'd say 20 years ago or so, that's when kind of like a beginning we can see, look back in history, and that's when kind of the Gen AI era kind of begins slowly. At that time, maybe not as noticeably too. However, there are already, a research being done to doing the feed-forward neural network language model. And then 2011 too is a bit of a breakthrough, I'd say, right? It's really, we're starting to see the emergence of this Gen AI kind of like a language kind of guided kind of thing. It's basically Apple, right? So I'd say, it's not like all brand new with this capability of analyzing and based on human prompts, right? We can tell, Siri, if you're an iPhone user, right? Its first iPhone with Siri started off in 2011, and it's using NLP assistant too to do it. But then earlier forms too, in that case, is kind of restricted to using, on the Siri on the iPhone. And then essentially, too, there are more research being done. So 2013 was in Google. It was they created Word2Vec as a technique for natural language processing that uses a neural network to learn word associations from a large set of text, and they convert it to vector, right? And so kind of like we see the beginning too, that is leading to where vector search similarity searches is. And then in 2017, I think folks, if you're have kind of been paying attention, right? There's this paper that says attention is all you need. It's basically, that's where it comes from. 2017 was the Google researchers. They proposed a new simple network architecture called the transformer. So if you kind of look up for the paper, and that's kind of like the punchline, attention is all you need, like that. So, okay, so that was just a very, very quick history. So then highlighting, what has happened, if we look back to 20 years. So it's actually, in computer time, it's kind of normal. 20 years, you can have something even within a year, big innovation, but the last 20 years, so quite a lot of things invented. So now then let's take a look at the players, right, in Gen AI. So we kind of talk about the model. So what are the models, right? So these are examples and highlighting a couple of the very well-known model. Of course, first and foremost, OpenAI is the institute, right, that kind of do a lot of research and also has funding, from other vendors as well. OpenAI, so it came out with GPT 3.5, and that model, right, that also came out at the time that's where ChatGPT is based on. And then you can also kind of look at too GPT-4, which kind of came out to just when ChatGPT 4 that came out in like last year in around the springtime too. So all kind of 3.5 and 4 kind of within kind of a year or even like 8 months with each other too. But they are the ones that powered ChatGPT. And then there are also other kind of applications that's you can build using using these models. And then there's also Codex too. Codex is actually what leads to or kind of what GitHub Copilot is based on, Codex. And then there's also Midjourney, for example. Oops, actually, I go a little sooner. But as we all know, there's also Stable Diffusion and also Dolly and Midjourney. These are more with images too. That's what it is. It's basically diffusion kind of method for Stable Diffusion and has led to Dolly and Midjourney. And then there's also Whisper, which is more on audio side. So these are just some of the kind of popular models. Now, the thing is too, what kind of makes it more useful is basically we build application on those models, or they're also popular kind of publicly available apps, right, that we can all use. For example, here, right, ChatGPT, we all know what that is now. Without kind of introduction, it was quite a disruptive thing, happened in 2022, November 30th, right? So it's just a little bit over a year ago, and we can already see like a major flood of things that are happening in the marketplace, a lot of hype too. But the thing is, though, is to really quiet down, look at what it can do and improve upon. I think that's what it is, not just like marketing hype, right? That's what I think. Okay, so then there's GitHub Copilot, right? And it's an app that we all know. And then the rest too, there's, for example, like Monkey Learn, that's also a simple kind of text chat provides you with the Chat GPT and not much code too. It's kind of a low code thing. And then there are also other, for example, like more commercial kind of Salesforce AI, Notion AI, SEO AI. All these are kind of more for projects and business side and marketing. And Bing AI, for example, that's also kind of coming up from Microsoft. And then there's also WordTune, for example. It's also a popular generative AI apps that are publicly available. However, public in the sense that some are kind of commercial too. So they built upon the models that I showed you earlier. So, okay, and then one thing to kind of also point out is that, well, now text to text, you kind of ask, the bot what you want, and it comes back with responses in the form of text. That's quite more common these days. But what is actually more kind of provide more value to us is basically this multimodal kind of way of doing things. You can be asking the question in the form of text in a language, natural language, and then again, I gave an example of real estate. It can be, I'm looking for a house. I need four bedrooms, 2 garages, and 3 bathrooms, and a large kitchen, something like that. And it will go and and does all the search similarity searches and comes back with you images of these houses and properties that you're looking for. Not only that, it's probably, you can also like provide link, right, to kind of, where are these houses? Are they on sale? Things like that. So it can do the text to image, or even, as we all know too, we're already seeing Copilot, that's text to code, right? And generate code for you. And also there's also audio too, obviously, right? We can be searching for some music, and I think that's pretty amazing, right? You can just say, write me a song, write me a song about let's say, about WeAreDevelopers. It's probably will go do searches and like that, and I don't have time here, but if we have more time, and like I said, I'm sharing with you my Twitch stream too, we can kind of do experiment like that and see what it can come up with, generate a song and write silly things, that type of stuff. And also video too, right? And it finds like a movie. I kind of wanted to see, well, for example, like history movie based on 1930s, something like that. It comes up with a whole list of videos for you like that. And then also three-dimensional things too. So these are multimodal. That's what it gives it more kind of add more value to this whole space, technological space. And how about the players, right? In terms of people, we talk more about the model, the apps, and all of these things, but there are people too, like ourselves, who are working in this space. But I wanted to highlight, because it's easy to say, oh, I'm working with AI, but there are different angle of looking in this and different needs for this. So like just right behind me over here, right? That's the data scientists, computer vision engineers. So these are like more, they are subject matter expert too. And as such too, it's interesting. I spoke to another fellow speakers, data scientist, and he was saying that, we have all this theory of what it should be, but we are not the ones to implement it. So who will be implementing are developers and engineers. So if you look over on that side, it's basically the data engineer. There's also a new kind of title coming up called AI engineer, ML ops. These are kind of more like specialized kind of engineers that are working with AI type of technology. So there will be also like prompt engineering. Yes, some of you have heard of, right? So again, what you expect, from the machine, you need to give it input that makes sense, that that will guide the robot, the bot, to kind of comes back with the answers that you need. So it is absolutely important that when you ask a question, you need to ask it specifically. So that's kind of a prompt engineering kind of space that there are also engineers working on that these days. And I also have to say too, sometimes prompt engineering may not be, kind of the actual people doing the coding. The coding people are, I'd say, more like engineers like ourselves. We can go and understand this, this context, and then being able to kind of do coding for it, right? So these, some of them dealing with data layer, some of them AI, some of them are just simply, software engineers too, but working in this space. And also ML ops that deals with deployment aspect, operational side. They're kind of extension to DevOps. So okay, so now then let's take a look. I kind of get too excited talking about everything kind of in detail, but let's kind of go through some of these terminologies. So GPT, Generative Pre-trained Transformer. So what it is, right? So essentially as such, is a transformer. It transforms data. So it takes inputs, and input are simple prompts like in natural human language forms as input. And then what it does is it does some pattern matching, right? Because in order for it to be able to find answers for you, it is doing these multidimensional searches. And these are pattern matches. And then it essentially answers the questions for the prompts too. And then what it does is that it transforms all of these things, and then it helps to essentially produce the contents, such as a new essay, a blog post, and a new computer program, and a new, design of a dress, and or kind of search for you, the houses that you are looking for. Is kind of transformative, right? It kind of transforms things into output and responses that you need. And essentially, too, let's also quickly take a look, GPT, too, as such, right? These are transformer that started off more like 2018, about 5-6 years ago now. There was a paper on GPT. That was the very early emergence of GPT, of a language model, right? Is basically GPT this first came out in a paper on OpenAI's website. But since then, too, there's all various research groups to kind of kind of going after this. They know that this is the thing, right? Essentially. Then 2019, that's when GPT-2 language model came out too. And I wanted to kind of quickly show you, if I have time, again, with JLlama, you can actually play around with the simple GPT-2 language model using JLlama, this Java library, open source library is developed by the architect at DataSex. It's kind of fun too. You can, I'll quickly show you, okay? So if you want to play around, but it's interesting, bear in mind too, I was playing around with it and came back with some answers that made me laugh, basically. But so if you're interested. So, okay, so now then kind of take a look a little bit further. 2020s is basically, ChatGPT is kind of becoming fast, the AI chatbot now. In Stable Diffusion, I talked about earlier, right? That's the generative apps. And it's basically developed by Stability AI. Actually, I should say Stable Diffusion is the model, I'm sorry. And a startup company called Stability AI, they use deep learning using text-to-image model that generates images that's based on text descriptions too. And it's a diffusion-based image services. So it led to like DALL-E and Midjourney. That was only like, less than 2 years ago. And with this, and then basically to GPT 3.5, that came out, and I already talked about it in November of 2022. Within like 5 days, right? Then the GPT 3.5 reached 1 million users too. And basically, it can access data from the web up to like 2021 too. So as you can see, I'll also discuss a little bit some of the not so desirable kind of side of things and all these things. So I'll kind of talk about later. But here too, in 2023, just last year, right? Once ChatGPT 3.5 came out, then a whole bunch of vendors, everybody's jumping on the bandwagon, so to speak. And Microsoft came out with Bing, and Google has Bard, and all of these, right? And basically, OpenAI too came up with a better version called GPT-4, but it's kind of a paid premium option too. And as such too, you can play around, and that's what I've also subscribed to, is GPT 3.5. Not as good as 4, but 4 is actually quite expensive too, I do have to say, if you pay it out of your own pocket. Anyway, then as we can see too, as we speak, right, ChatGPT continues. There are lots of confusion too. At the same time, there are a lot of companies, lots of people, individuals trying to invest and trying to monetize this too. And that's this scenario. Okay, so now let's take a look at NLP. What is it, right? NLP, as we kind of take a look, it's basically an interdisciplinary subfield of linguistics of computer science too. And the concern is to process natural language data sets, and that's such as like large text corpora or speech corpora. And it uses like rule-based or probabilistic machine learning approaches to process input, so to speak, right? Prompts that are coming from, kind of like people asking questions like that. And it enables the computer to learn from the contents, including the contextual and nuances of the language itself. So it actually goes beyond just, kind of like, typical, like a traditional computer commands. You say, can you do, find me something, and it goes and look for you, find you something. But the NLP part is actually goes beyond just that. It can be able to find, kind of similar type of results for you too. It helps in that sense, right? Okay, so it helps you to also draw insights from the document as well. So. And now then let's take a look too in LLMs, right? These are large language models. And basically too, it's a type of machine learning model, right? And it's foundational type of model. And it's typically too, is the pre-training consumes a humongous amount of resources, right? As you can see, you need GPUs, first of all, to train them, especially these foundational type of models. And it takes weeks, if not months of, kind of training time too. And it's not for ordinary citizens like us, it's just we cannot afford it. So these are usually being done by huge kind of companies or organizations such as like OpenAI, funded by other companies as well. These are foundational model, and it performs like NLP tasks. And it also generates and classifies the text and answers questions, the kind of essentially it comes in the form of prompts, just like a human, right? Analyze the sentiments, chatbot conversations, all of these things. And that's what large language models are capable of. And as such too, LLMs is what we kind of mostly, right? Well, developers too, that's what we interface with the LLMs. And they are the ones that are kind of doing all the magic behind the scenes. So this one is a diagram that kind of describe, if you kind of look back in my slides and I talk about just the onion peeling like 3 layers to it. AI, machine learning, deep learning. So if you go deeper into deep learning, as you can see, deep learning, right? There are different techniques in here. There are ANN and CNN is concurrent neural networks. These are like approximate. Actually, I cannot remember the ANN, but anyway, these are NN stands for like neural networks, different models of it too. RNN is recurring. Actually, C is concurrence and also recurrence neural networks too. And then there's also Gen AI. Gen AI, again, all the transformers that we talk about, GPT kind of falls into Gen AI category. And then there's also image generation and also LLMs. These are true like large language models, transformers in there as well. And then the NLP is what kind of like this discipline, right? Things that LLMs is basically kind of help, essentially relies on NLP or actually performs NLP tasks for it. It's more specific inside this NLP. So as you can see, this is how it looks like, conceptually, if we have to kind of draw a picture to it. Now, some examples of APIs and frameworks that we can work with is basically, I think a lot of you probably have already worked with and maybe starting to work with is LangChain, right? And also Llama 2 as well. Llama 2 came out from, well, actually, I should say Llama 2 is Facebook, right? Meta. And then there's also Llama Index too. That's also like it deals more with the retrieval and processing side too, and Llama Index. And then also Palm, that's actually comes from Google, that can work with is Vertex AI, their AI API, right? And then also Hugging Face, and this one, Hugging Face is an open source platform. It's sort of, think of it like AI, like a hub, So basically, too, you can also get an account, and essentially, too, there are many models that folks, we can kind of think of it like public place where people can train their model. And obviously, these are not foundational type of models, but you can upload your model. But I'd say, too, you still would need a fair amount of resources in order to process it. I tried to get to some of it, and some of them, is basically, they are really huge too, but some are kind of smaller. For example, you can find GPT-2 like a medium kind of model that you can play around with. If you want some laugh, you can actually use JLlama to kind of use it and essentially run that, and it brings up a simple chat bot. You can actually play around with it too. So, okay, so now then talk about these API frameworks, right? These are Java-based one. So JLlama, as I mentioned about it, is developed by Jake Luciani, who's the chief architect at DataStax and JLlama, and currently is still in beta version. So if you go to its open source, it's not associated with our company directly, but he comes from our company too. So JLlama is pretty cool. If I have time, I'll quickly show you that. And then there's also JVector, which is developed by our technical co-founder, Jonathan Ellis. And JVector is basically based on approximate nearest neighbor kind of algorithms. It uses that, and essentially to uses DiskN, which is developed by Microsoft. It's super fast too. And so it essentially enables the underlying vector searches underneath the hood to JVector. And then there's also a Java port. I shouldn't say port because it's not really like porting it, so to speak, but it models after LangChain is for Java. In Java, that's LangChain 4J. And that's basically too, it's sort of at this moment, it's not like a full set of what LangChain is doing, but definitely too is like the closest cousin, I'd say, to LangChain. So LangChain 4J. And then there's also Llama 2, and it's direct port from Llama C2. So these are some of the Java-based API frameworks that you can consider using, essentially. Okay, so now let me then get into vector database and vector search. So what is vector database, right? So now the thing is too, is that it's true, you don't necessarily need a database. However, you are like processing a huge amounts of data. Let's say, you're dealing with chat, the chat kind of go back and forth, but there's some ways you want to save the chat history, for example, things like that, right? So it's best for you to store them in a database, an external thing, not just in memory, right? You can have in memory a database too, but having a vector database certainly helps a lot too. So vector database is a purpose-built database that serves up vector data type for complex machine learning purpose. And as we can see, right, machine learning, now we're dealing with data that essentially too, you want to support different patterns, different dimensions, and all of these things. So just the traditional scalar way of storing data, querying all of these is not sufficient for doing this kind of ChatGPT type of similarity searches. So that's when vector database come up. Essentially too, vector database relies on vector embeddings. Vector embeddings are essentially numerical representations of the data that are stored in vector database. So I'll give you a quick example. If you have a string that comes in, right? Let's say you need to convert it to vector, you need to first convert like a normal string into vector embeddings. So vector embeddings are numerical representations. And if you take a look into our Cassandra database, Apache Cassandra is essentially it provides you the data type that's an array of floating point numbers. So these floating point numbers have been converted from certain strings, and it's essentially stored as array of floating point numbers. And so that's what it is. A string comes in. What first you would do is tokenizes this string, right? You kind of break it up, parse it, takes all of the words, and then from each word, you will convert it to some numbers. And numerical, they are floating points. And you can, most of the time too, we're using OpenAI specifications for, kind of converting them. And then from there, then the vector database can then perform queries, and you can store it and doing searches and all of these things on it much easier and super fast too. And that's where like JVector I mentioned earlier too, it handles this kind of like searches for you super fast like that. Okay, so if you kind of think of vector database as a form of feature engineering. So in machine learning terms, feature engineering is essentially you are kind of engineer, you are kind of providing data for doing fast searches. So in some ways too, is that vector database is within this category of machine learning feature engineering too. And again, I mentioned earlier too, is using this technique called approximate nearest neighbor, ANN, for it. So now let's kind of take a little bit closer look of the mechanism, right? So now, folks, if you're a math background, this isn't too foreign to you if you are familiar with linear algebra, and that's what it is coming out of, right? And I also have to mention, I was actually math and computer science major when I was at university, graduated with math and computer science. So I finally, in my very first job in many years, I was just all computer and kind of helping IT department, fixing problems, a lot of times, and never really get to this, but I'm so glad I'm finally actually working with something that's math related. So essentially too, is two dimensionals. If you kind of look into the data itself, it's no longer you are storing data in scalar format. It's not, single dimension, right? We're talking about, these are multiple dimension type of data. So it's a bit abstract, I have to say, if folks, you find it a little confusing, don't feel bad. The thing is, it will take a bit of time to understand this type of representation of the complex data that we're dealing with every day. So essentially too, an embedding model would transform the text into a vector called an embedding, and the embedding can be however many dimensions to it too. So for example, like OpenAI's embeddings, they are 1,536 dimensions, and actually I believe the 3.5 GPT transformer, that particular embeddings, I think they're up to like 16,000 or 15,000 now. So, and basically too, if you kind of take a look at this example, right? How does the data get stored in space? And essentially just space, don't even talk about time. So basically XY coordinate, you can see data is being kind of represented, in this space, and that particular point is vector 1. That's where it's located. It's not only the magnitude, it's also the direction where it is to within this two-dimensional space. And then there's vector 2, an example here, and also vector 3 is over there. So you want to try to find out, let's say a prompt comes in. That prompt too might be somewhere in the middle, something like that, right? So it can be, then that's where the algorithms is going to find out my query is here. I want to try to look for a data set of data, the data that's closest to me. So then you have to search and look for where, with this within this two-dimension, where is it closest to? And that's the idea. Okay, so this kind of like gives you a real example of the word or a block of text within its context. So the dimensions are basically result of the LLM training too. So, and if you kind of take a look at it, right, previously we kind of just show you some arrow. To you, it doesn't make any sense. However, if you really put a word in, it can be cat, a dog, a house, all of these things. So they has its own kind of like location within this two-dimensional vector space, right? So you can take a look at this, and then basically too, you are kind of looking into another question that comes in. It could be somewhere over there, and then it will try to search for the points that are closest to it within this two-dimensional space. And I hope that kind of helps you a little bit. Now, if you want to get a bit more into vector search in more details, and here's another kind of explanation for it too. So there's basically vector store and vector database. These are embedding storage, like with or without metadata, depending on the database too. And there are built-in algorithms for fast retrieval of so-called like nearest neighbors embeddings, right? So for example, HNSW, hierarchical nearest search something. I'm sorry, this one I should have remember. I knew it, but okay. So just to give you an example too, HNSW is also quite widely used, and in fact, Elasticsearch, and that's the approach it is using, is HNSW. But for example, JVector, as I mentioned too, it's basically used for Cassandra, Apache Cassandra search now. Now, it first came out too in our company, so we apply it to our managed cloud Astra database, our vector database. And that's JVector, again, developed by Jonathan Ellis from our company. And basically, too, it uses disk-and type of algorithms. It's approximate nearest neighbor, but a specific implementation from the research at Microsoft, too. So it's also like actually much faster than HNSW, too. There's also, I believe he has published a paper on that particular kind of benchmark, too. So if you're interested, let me know. Okay, so if you kind of take a look into vector search, right, and basically it's called like the different layers of searches. And again, I won't get into, a lot of the details too, but if you're interested too, it involves a lot of the mathematical theories within it to kind of locate, kind of like answers to what you're looking for too. And so essentially, if I sum up, is that vector database, all of these algorithms are super fast. We're dealing with a lot of data within, this two-dimensional space, but it can also be layered. So it narrows it down into specific search results that you're looking for. So for example, Cassandra has it now. It came out to the GA of the vector search came out. I think came out of Cassandra 5, and DataStax Astra DB already came out with vector data type back in the summer of last year. And we kind of provided, because we participate in the Apache Cassandra project, so we also contribute back to the Cassandra ecosystem. Okay, so here, let me kind of quickly kind of explain what are vector embeddings being used for, right? So essentially, too, for similarity searches, and basically, too, when you do searches, too, you also have all the results that comes back, because it searches for answers for you, not just exactly what you're looking for, although you can specify to narrow it down, but essentially, too, it searches a whole context to it, allows you to do that because of this technique that it is using. And basically, it ranks all of your results too by how close it is to your search string. So doing similarity searches, and you can also be using for clustering as well, right? Where text strings are grouped by similarity, and then also using for recommendations. If you're using for shopping cart kind of thing, you can use vector embeddings to help you to do recommendations too. And then there's also anomaly detection, where outliers with little relatedness are identified. And also diversity measurement. So you want similarity distributions, you want to analyze it, you kind of measure, the diversity within your data set, for example. And also classify your text, where text strings are classified by the most similar label too. Okay, so just kind of like a question too, maybe folks are saying that, can we use traditional database in ChatGPT AI, right? And certainly you can use, but I wouldn't recommend, because now, as we can see, the data that we're working with in this space is becoming more complex. It actually requires a database that can handle multi-dimensional representations of your data. But traditional databases are dealing, essentially too with scalar data type, so it's not capable of quickly kind of sort through all of these complex data that's required in AI to handle the dimensions, the patterns, the relationships, all of these things. So it's not already built in. You can still force it to do the work for you. And for example, things like SQL, we know that we can do searches, select something from a table where, A equals 2 plus 3, something like that, right? So it will look for exact answers for you. But then the thing is too, you want to do similarity searches, you probably will require a lot more computations in there. And not only that, the performance probably won't be good. So I wouldn't recommend that, even though you can still do it, but you have to wait for days before you can get the answers. Okay, so now this is an example kind of model to explaining some of these ChatGPT, from the simple things. We kind of talk about a lot of these things here. And this is kind of an example how the vector database kind of sits, within the ecosystem too. As you can see, you have user input comes in as prompt, and then it goes through here in this whole LLM chain in here. And essentially too, you can think of the database, vector database sits in here, provides all the embeddings for the vector data. And it's basically data coming in, dealing with stateless processing of the embedding services. And it augments, essentially too, LLMs are limited by itself because you have to do this huge set of data, kind of processing and generate the models, but it takes days to do it. So essentially too, for example, ChatGPT 4, I think it has data from 2022. And so basically what happened in 2023? So those data isn't already inside your ChatGPT 4. Like ChatGPT 3.5, it has data up to 2021. So what happens if you're searching for some data that's actually occurring that needs to happen in 2021 or 2022 even, for GPT-3? Then you have to have another way. So basically using what is called like generative AI apps, this retrieval augmented generation, RAG, in the middle of here. And that's what a pattern that it kind of enables you to kind of, be able to supply it real-time data for all of the processing, if you kind of take a look into it too. So then ultimately too, it's basically going through all of these, and you can then generate responses that can essentially be more up to date in that case. Now, if you don't use RAG, then most likely some of the data you won't be able to get because it's not already inside the LLM. So okay, so this will be, I think I may have like 5 minutes or so, maybe. Let me kind of quickly show you an example. I talk about Astra vector database. If there's time, I'll quickly also show you the JLlama too. That's kind of exciting. Okay, so here, this one. As you can see over here, actually here, this is the link. Now the link, the URL too, I think it's kind of becoming quite small up here, but I will be sharing this link with you in the slide deck. So I will also be sharing with you. First, actually, you will just need the slide deck, the URL, and then inside I will have the URL and also the bit.ly link to for you to get to this page, and essentially for you to sign up with our DataStax vector database. And I wanted to share because you can use this for free for up to $25 US dollar per month, and you get another renewal of $25 in the next month, for example. And so it's quite nice. And all you need to do is sign up. And let me maybe make this a little slightly bigger. So there's also a sign up in here. So if you click on that, you'll notice that here. So you can sign up for free, and then using, you can do single sign-on using GitHub or your Google account too, if you don't want to sign up and giving your name or last name explicitly, right? And then you can give your email, and we do not ask you for your credit card. So that's how much we kind of wanting you to succeed as well. Okay, so in my case, then I have already signed up. So I'll just sign in with my Google account. Okay, and it's kind of like quickly. So over here, as you can see, you come into our, let me kind of make it slightly bigger. So the thing is, over here, you can do a create vector database in here, and you can kind of quickly do that. And basically, too, if you want to play with non-vector database, the Cassandra database, you get the same $25 within your given credit every month. So that's kind of nice. And basically, here I want to create a vector database. You just give it a database name. Let's say we are call it WeAreDevelopers database. But I think now mine is not going to be working. I'll tell you why after. But I just want to show you how easy it is to set up your own vector database instance in our managed cloud. And let's say I want Google Cloud, and then I am in the US, and so there's US East, and I create. Now, the thing is, over here, it says database limit reach because I already have one created. But then if you haven't, then you can create one too. Now, the thing is, too, is that if you are a startup company and you would like to have more credit to maybe do POCs, proof of concepts for your company, we will be gladly helping you out as well. So just talk to me about it, and I can connect you with our teams that are helping you to onboard. And there's no obligations to. Another thing is you can do your initial testing on it and give essentially pay a small amount, and then you should be able to use it for up to, I think you also get support from us too. So that's what it is. So I've created my vector database already. So let's take a look. You can also go to the left side. This column show you all of the database. And actually, let me kind of look over here too. So if I click on databases, as you can see, there's a December 23rd Azure. That's what I've created in here. So I can kind of do a quick connect. And over here too, and that's what you can kind of do. And also too, wanting to introduce to you a new data explorer too, is a public preview in this case. And it's basically, it gives you a very easier kind of way of onboarding you to use our vector database. So let me kind of do that, and I can do a continue, and basically it's over here. And I've already created a namespace called vSearch, right? And create a collection. I can do that. And a collection name will be like, kind of we are dev, for example, devs, and like that. Enable vector, right? And how many dimension I can do, maybe just a smaller one, for example, vector length in my data set, and then I can do similarity searches. And again, also kind of pointing out too, for doing similarity searches, there are different kind of algorithms that you can pick for doing it. Is either cosine similarity, dot product, or Euclidean distance too. You can do all of these to calculate these vector similarities. So let's say I want to use cosine similarities, and I create my collection. Okay, so I gotta pay attention to the time now. I think I'm almost like talking for an hour. But as you can see too, I created my collection is essentially too. This is the collection, and there are 300 dimensions, cosine, and how many records. And in this case, I can load the data. So I can select a file that's already been pre-populated. So it's actually quite good, right? Isn't it? Yeah, quite easy to do it. And essentially too, I can also go to what is called CQL console. This console is basically allows you, think of it like CQL is Cassandra query language, but it's similar to SQL as well. So it's not much of a learning curve as well. So this is the console that comes up. And as you can see over here, so let's say, right, I want to use vSearch is my, my namespace that I've created. And I think I already created a table called search products. Oh, okay. I guess I have, sorry. Star from vSearch.products. Oh, okay. Sorry. I guess it doesn't exist, or is it product? Okay, I think maybe I didn't do that. But the thing is, though, I wanted to show you, right? How would you create a table? So essentially, you can just do create table vSearch.product. And then essentially, too, you can do ID integer, for example. And then you can also do vector data type. So item vector, for example. And then you can do it like vector. And again, it is, you have to specify like this is a floating float, and then like say 5 dimension in here or 4 dimension, something like that. So you can, oops, sorry, I think I kind of completely forgot about this thing. However, let me kind of quickly show you. If you kind of stuck, you go to this over here, it gets to your our database document. As you can see, like the bottom there's like a book. That's where the documentation is. And then you can kind of do a quick start in here. And it kind of shows you how you can do it too. So pretty nice, right? How do you create a serverless database, which I did, and install the client, initialize the client, load the vector embeddings, and perform a similarity search and run the code. So you can basically also step through in here too. Now, I realize my time is kind of coming up. I don't want to hold up folks, and you've been here for a long time. So again, you can kind of sign up for our vector database. And again, there are plenty of help in here. You can always reach out to me as well. So I'm going to go back to my, my slides again. So I hope that was helpful. And if you want to sign up for this, right, again, I think I might be blocking you, but if you want to take a quick look at this, but let me then also do this one thing first and move out of your way. And so you can take a picture. So yeah, so yes, so do take a picture, sign up for the vector search, and I hope it will be helpful for you. And okay, and okay, so now let me really quickly kind of summarize benefits, right, of similarity, or kind of vector database and generative AI. Basically, ask, you shall receive, right? Make sure you ask wisely, and that's where you need to do, right? Your prompts have to be quite smart about things. So sorry, I guess I'm like in the wrong thing. Okay, sorry. Let me kind of go back. Okay, and okay, some challenges too. Now, as much as it is good, it's basically you have to be aware of the issues too. There are hallucinations, right, that are kind of, as we all know, right, that's kind of not so good. So be careful, right? If you're using some model, it's gonna come back with you wrong answers too. Let me kind of switch myself over there. So. All right, so that's that. And also too, there are ethical concerns, as we all know, right? AI, there's nobody to oversee the usages. There are lots of questions about, you're asking questions, these public models, they're gonna save your data. So be very careful. There's no regulatory kind of like restraints and constraints overlooking it. And, as such, use it with care and don't be intentionally malicious, all of these things. Now, how about real-time, up-to-date data? As I explained, right, LLMs, you only serve up to a certain time. So if it's over that, let's say if some data is outside of that, then you won't be able to search for it. But you can always use RAG pattern for LLMs as well. So that will be another talk that I have done too, if you're interested. Okay, so these are some of the resources. This slide deck can be accessed here. So just access my slide deck, and then you'll be able to get the rest of the information that I've talked about here. How do you, for example, like how do you sign up for the Astra managed cloud platform? And so I'll kind of leave this up here for about 10 seconds. And then if you miss it too, what I'll do is I'm going to share this with the organizers. You can also get the information from the organizers too. So, okay. All right. And okay, so it's good. Or maybe you can find it on the recording too. So I'll go forward. And these are like links as to how you can reach our, all of the various, information that I presented here. And then also I have my Twitch stream, as I mentioned. This is my Twitch channel if you'd like to follow me there. I plan to do something even this afternoon too. And some of the things as I was talking, I thought, let me kind of show you. For example, J Llama, I can show you this afternoon too. Or actually afternoon for you will be nighttime. So I should say that. Okay. So with that, I want to thank you very much. And again, thank you so much to WeAreDevelopers for giving me this chance. And I know I've kind of gone over time, and really thank you for this opportunity. So.
Hello again, Mary. Thank you for the talk. And time-wise, not that big of a problem since you're the final talk. I mean, earlier would be a bit of a hassle for you with the time difference, I think.
No problem. Yeah.
Thank you really for taking your time and elaborating on this topic. If you still have 1 or 2 minutes, we have one audience question.
Sure.
If that's okay with you. And it is it correct that values of the vectors are model specific?
Oh, values of the vectors are. Oh, I see what you mean. You must be asking about the vector embeddings. It is very true if you're asking about, when it gets converted to the embeddings. Again, when you generate it too, you do need to specify which model specifications you're using. So most of the time too, basically we're using the Open AI specific model. I forgot exactly the name of it, but yes, they are model specific too if you're asking for the embeddings. So let me know if I answer your question. Yeah.
Yeah, we will also include your QR code in the recap. We are sending out a recap newsletter 2 days after the event, so people can reach out to you and get all the information.
Thank you. That sounds good.
All right, Mary, thanks
Okay.
so much for joining us again. It was
Thank you.
a real pleasure having you again. And yeah, I would say hopefully until next Live Day.
Yes, yeah, that would be great. Yeah, thank you. Thank you so much, Benedict. Thank you again to Vincent behind the scenes and also behind the scenes folks, Nick and everybody
Yeah,
too. Thank you
excellent.
so much. I really enjoy it. Yeah, thank you. Have a good evening. Bye-bye.
Thanks, Mary. Have a nice day.
Thank you. Bye-bye.
Bye. All right. And now that also the final speaker is done, also this Live Day comes to an end. Now is the time for you to go to worldcongress.dev, where you can get further information about our in-person event that's happening in July in Berlin. And you can also, for now, buy the tickets for a reduced rate, so be quick on that. Also, thanks to our partners, without whom events like these wouldn't be possible. Scroll down on the live page, we link their logos and check them out. And hopefully we all see each other next week on January 24th, when it's all about Rust. See you soon.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.